Welcome to our Getting Residential Right in Dublin virtual event. Ireland is facing a significant shortage of houses. The high demand for homes is leading to problems like a higher number of evictions, high rents and homelessness. In fact, homelessness has nearly quadrupled in the last 5 years, according to the Irish government. An estimated 35,000 homes need to be built every year for the next decade to bridge the gap between the supply and demand. At this event, we will explore topics such as off-site and modern methods of construction and the role they play in achieving well-designed and quality buildings while saving costs and maintaining high standards. We are joined today by our panel of experts who will be part of our live Q&A at 1 p.m. If you'd like to ask any of the panel a question, please scroll down to the Slido link. If you've joined us by Zoom, click on the chat and you can pose your question there. Today joining us, we have Elston Gurr from Sapphire Balconies, Laurie Pomeroy from Duty Point, Andrew Parsons from Sapphire Balconies, Archie O'Donnell from i3PT, Richard McMullen from MyDeck, Derek Russell from Techcrete, and Nick Horton from Sapphire Balconies. I would now like to introduce Elston Gurr. Elston will be talking to us today about better costs through hypothesis.
Thanks, Kelly. My name is Elston Gurr. I'm the sales manager here at Sapphire Balconies. One of the things that digital can do for us is help us compare different forms of construction in a variety of ways, involving the buildability, but also the commercial side. Are there any potential hidden savings from comparing these types of construction? Today, I'm going to be presenting something that Sapphire have explored in the marketplace on how we can bring a better balcony solution to the table. We talk about a number of benefits, but we don't often talk about how those benefits can tangibly form into commercial savings. Hence, I've called this presentation, There's Definitely Benefits, but where's the money? So let's talk about the speed of installation in a bit more detail. Sapphire have installed 34 balconies in just 6 hours. That's our record install. Now, we can comfortably say that we can install 10 to 15 balconies a day. On average, conservatively, 10 to 15. So how can we take this benefit, this potential benefit, and save you some money on your project? Well, let's talk through a live example. Let's say a balcony scheme has 250 balconies, and a tower crane is the most common form of installing a balcony. Tower cranes cost, from market research and a lot of client feedback, approximately £5,000 per week, once you include a driver and the ancillary items. So typically we would be installing on site for about 3 days per week. Therefore, we leave 1 day to be winded off or another day for the tower crane to be used for something else. We all know that hook time is very precious. So a couple of quick calculations. If we were installing 15 balconies a day, that's 17 days of install. Put that into a 3-day week, 6 weeks total install time. Let's consider other methods of installing balconies, such as a bolt-on. A bolt-on, about 5 balconies a day you're going to install maximum. Based on a 3-day week, we're looking at 14 weeks of installation time. So, simple calculation, we would save on a 250 balcony scheme, conservatively, hypothetically, 8 weeks. Times that by £5,000 a week, £40,000 saving. That's where we can see, program-wise, where we can bring something to the table. Don't forget, there's also many other forms of installation, such as mobile cranes. Being a lightweight balcony system, let us explore with you different ways that we could potentially install those balconies. The second major benefit that we believe we can bring to the table is reducing the number of castings or anchors on site. Sapphire, over the years, have worked with many third-party anchor companies. However, we never felt comfortable with those anchors, particularly because we wanted to come up with a very strong and robust anchor that took out any balcony bounce. Therefore, we've developed our own Sapphire M30 anchor, which has a 30mm thick stud included in the anchor. Now, consider the balcony frame itself. It's an aluminium chassis, therefore very lightweight. Once you combine the strong, robust anchor with the lightweight chassis, you have a very rigid balcony. Secondly, we reduce the need of the number of castings that is typically specified by your architect or structural engineer. Let's give you an example. You can see here a corner balcony. Corner balconies are very large balconies, therefore often requiring a number of castings. In this example here, we needed 9 anchors, so 9 third-party anchors. With Sapphire, after some structural calculations, we're looking to use 7 anchors. Let's play this out in another example. Taking the 250 balcony scheme that we spoke of earlier, on average, that scheme would probably need 4 third-party anchors. If you're using a Sapphire anchor, we'd probably need about 3. Therefore, on average, 1 anchor saved per balcony. Take that scheme in total, we would be saving about 250 anchors across the scheme, a significant number of anchors. What's detailed here is what is the typical cost savings by not having to procure that extra anchor. And we split this down here into the cost of a bracket, the cost of a stub. Then we have the reduction in the frame contractor setting out those different anchors. There's a labour element there. Then we have waterproofing and fireproofing. Now, these figures have been tried and tested in the marketplace, and we're very confident that these figures will stack up in your cost plans. We believe we can save £475 per bracket. Therefore, take those 250 brackets we're saving, you then get £118,750 saving on your scheme. So what we're really doing is highlighting some of the hidden savings that you may not think about when you're first planning your project. Therefore, we ask you to engage with us early on with your architects and structural engineers to design in our bracket to bring these savings to the table. Let's look at a summary. The summary here for a 250 balcony project scheme would be saving approximately 40 grand on the crane and approximately 118,750, giving you a total of 158,750 on your scheme. This is a very simplistic look at the project. On your Pacific project, we would go into a lot more detail about where we can bring savings. There's drainage. Our balcony system doesn't need any downpipes. We can also do a very strong comparison with concrete. We can remove downstands, propping, and much more. How does this link? How do we bring this all together? How does it link with the new digital age? Well, we've created what's known as the hypothesis tool. And it is a simple document where we put in project-specific data around your project, and we actually explore the project-specific savings. We're putting technology into this. We're looking at a computer-aided balcony design tool, which builds the project visually and then shows you the savings that you can bring to your scheme. So in summary, there's a number of key takeaways from what we've been discussing. Explore benefits that different systems can bring to your project. Work with your specialists to identify commercial, tangible savings that these systems can bring. We're also very excited to be incorporating this into our configurator that we've already developed and are continuing to develop. We can then give you an overall picture of the buildability benefits as well as the commercial savings. Many thanks for listening. We'd love you to get in touch with us. My name's Elston Gurr. I'm sales manager here at Sapphire. I also have an excellent team that would love to talk through any project-specific savings that we can bring. Tim Ward, Director of Client Relations, Lee Goodenough and Paul Thompson would happily take your inquiry to talk you through. Many thanks for listening, and we look forward to working with you soon.
Thank you, Elston. We'll now be joining Laurie Pomeroy from Duty Point. Today, Laurie will be talking to us about off-site manufacture pods.
Hello, my name is Laurie from a company called Duty Point. I've been asked to speak today about off-site manufacture pods and present a case study. So a bit of history on Duty Point. Duty Point was founded in 1976 under the current ownership since 1995. Traditionally, we started as a pump distributor, selling to smaller pump distributors and motor rewinders and repairers across the UK. In early 2000s, we started manufacturing cold water booster sets, and in 2005, we were the first company in the world to get RAS approval on a full booster set. We are widely known as a cold water booster set and pump system manufacturer. So in 2017, we started manufacturing packaged utility rooms, and this has now become a key part of our business. So our purpose, why we get out of bed in the morning, is to reduce construction complexity by creating off-site packaged solutions to setting the bar in customer experience and innovation. I'd like to hone in on the reducing complexity and customer experience, as these are 2 points we are very, very precious about. So today I'd like to talk about a project called Prince of Wales Drive. It's a Barclays project for 394 apartments. We've recently delivered our first lot of units. So here are the units. They're 1200 wide by 780mm deep. These units are ready to go out, and as you can see, they have protection at the side frames. We've actually fitted temporary lockable ply doors for extra protection. The key components within the unit are the heat interface unit, a tenant valve and water meter assembly, the consumer unit, underfloor heating manifold, provision for an electric meter, a box for your audio, your heating controls, a 6-gang grid switch, and an LED light and PIR sensor. The unit has adjustable feet and a removable transport bar. Once the unit is in position on site, the screed will go into the unit. There are also wheels inset into the frame to move these units short distances into the final position, and fork pockets for moving the units with a forklift. So there's 2 main areas I want to concentrate on today. One being the importance of upfront thinking, and the other being how you must identify pain points, and if possible, reduce them or even get rid of them. So on to upfront thinking. The schedule is one of the things you must put time into upfront. So can you actually deliver the first lot of units on time, and then can you meet the program through the project? Prince of Wales Drive was very, very tight. We ended up with only 4.5 weeks from design freeze through to delivery, which was a massive challenge. The only way we've managed this internally is to set key milestones for everybody involved and get the team together on at least a weekly basis to hold each other accountable. I'm pleased to say we hit our first delivery on time. The other item you must put upfront time into is making sure that you've got every bit of equipment included early doors. This is a challenge, but it is not always easy to get this up front. Logistics to site is another item you must think about early doors. We were presented with a fairly major challenge on this project. They wanted these units delivered on their backs rather than vertically like we would normally supply them. When it came to loading them onto a truck, this meant we could get only half of the usual delivery. We've come up with a method of double stacking these, which has enabled us to carry out normal delivery sizes. If we had not thought of this early doors, it would have been a major problem to us later on. The other thing is the actual offload and final positioning. How the unit actually comes off the truck and gets to its final position. Again with this project, because it was coming on its back, it was a major challenge. We set 2, and our innovation team had come up with a unit to flip the trolley from horizontal to vertical safely on site. I'm going to show you a quick video of this now. So as you can see, this is a very safe way of flipping units on site, and it's been a great success. The other item you must think about up front is project-specific QA and testing. On Prince of Wales Drive, the client actually visited us on 2 separate occasions, and we went through the QA in great detail. And testing. What standards do you need to test this to mechanically and electrically? This can obviously vary per project. So to go on now to identifying pain points and reducing them where possible. It's actually key you do this for a smooth delivery of the project. One of the items which is always a big issue is free issued equipment from the customer. This needs to be well managed. If it's not well managed, it will let you down on the schedule for the project. The other thing that needs to be given great thought to and is often left is how the unit integrates with the building. So how it actually fits in with the door frame, etc. There's no way around this than actually thinking about this up front. One big pain point on pods in general is leaks. This is a massive challenge, and I believe that it's one of the biggest challenges that developers face on off-site manufacturing. We've invested in a CNC pipe former to try and reduce these. I'm going to show you a very quick video now of it running. Investing in this machine has enabled us to reduce the risk for leaks. On one particular project, we actually took out 24 elbows, which is 48 potential risk points. It's actually leak prevention rather than leak reduction. Schedule changing is also a massive issue when it comes to manufacture of pods. This isn't as easy to manage as it would be if you were building traditionally. We've now insisted on a 2-week window where we cannot change the schedule unless something catastrophic happens. So to conclude, if you're doing off-site manufacture of pods, you must put sufficient upfront thinking. It will go wrong if you don't, and you must identify the pain points, reduce them, get rid of them if you can. Thank you very much. Have a good day.
Thank you, Laurie. Remember, if you have any questions for Elston or Laurie, please scroll down to the Slido link and you can post your questions there. I'd now like to introduce Andrew Parsons, who'll be talking to us today about effective water management of balconies.
Good day, it's Andrew Parsons here from Sapphire Balconies, here to speak to you about water management of balconies. I've been with the company Sapphire for 28 years now, since its inception, and over the recent years we've concentrated 100% on balcony design, manufacture. Our head office is in Reading, where we employ about 60 staff, and we've installed approximately 15,000 balconies over the last few years of this slide-on concept. I've also been on the committee for the BS 8579 legislation, which is shortly to be released to the public, which concentrates and gives a lot of guidance on balconies. This CPD will be covering just a brief introduction to balcony design. The 3 main types of drainage will be touched on, and then also how we communicate that information via water management plans. Sapphire balconies are made primarily from aluminium to keep them lightweight and rigid. So this is folded sheet and components. There's an aluminium decking, which on that picture has been removed, so you can see the structure of the balcony. So the water that falls on the balcony is allowed to fall between the decking down to the soffits, and is then dispersed with in a variety of ways. There's one common misconception about balconies and the difference between these and flat roofs. Often the guidance is quoted that 6 square meters is the maximum size of balcony that can be used without positive drainage. That actually comes in England from the roofing standard, dating from the days when a lot of balconies were cast in concrete and attached to the building. And like on any roof, the waterproof membrane on the roof is actually integral with the building waterproofing. And so there's a very large desire there to make sure that the balcony can't pond and flood over any threshold or over any waterproofing layer, and that the water is allowed to escape. The modern metal prefabricated balcony, however, is a completely different concept, in that the building waterproofing is intact on the outside line facade of the building, and the balcony is an addition to the building, and therefore can be regarded as the water management of that balcony can be regarded as a completely separate issue. Those hand-drawn sketches hopefully illustrate those two concepts well, and you can see in the photo a typical penetration that is used to connect the balcony, and you can see how the waterproofing, even on quite a complex facade there, is actually completely integral and continuous across the stub, so that any water on the balcony bears no relation to any water that might get into the building. There's a number of relevant pieces of legislation that apply when looking at drainage. Obviously, the first one we look at is the approved document. In this case, H covers drainage, but that gives some generic advice, but where more specific advice is needed, there's a number of other standards, and then there's also this new British standard, which is just to be published, which is 8579, the Guide to Design of Balconies and Terraces. These three diagrams here will probably help illustrate how balconies actually protect the building rather than contribute to any possible water problems relating to the building. The left-hand diagram shows rain lashing against a typical facade. In the UK, under the British standards, it's assumed that the rain will come down to the maximum angle of 26 degrees from the vertical. And you can see there that any rain hitting the building will actually collect and run down the face of the building because it's got nowhere else to go. And there'll be quite a concentration of water at the foot of the wall, which will need dealing with by the drainage system. The central diagram shows what happens if you start to introduce balconies with an open or vertical bar railing. You can see there that the top balcony will collect a fair degree of water, but subsequent balconies under that are shielded or protected by the balconies immediately above them in the stack. And the amount of water that actually hits the facade is vastly reduced, and as you can see there at the bottom, the wall is possibly not even getting wet. So the third diagram is an indication of balconies where there's a solid or glass balustrade, and you can see there that the majority of the water, especially in a high stack of balconies, actually hits the face of the balustrading, and very little actually penetrates and gets onto the general balcony decks, apart from the top one. That can be illustrated in the picture on the right. If you look carefully, you can see that the top balcony of that stack is fairly fully wetted following a rainstorm. The next balcony has a degree of water on it, but you can see, if you look closely further down, that subsequent balconies are almost completely dry, and that just helps illustrate that concept. So there's three main means of controlling the water on balconies. One we're not dealing with really here is where you don't have any control at all, where the soffits or the balcony doesn't have soffits, or else they're perforated and the water is allowed to just perforate freely from one balcony to the next. That is been done traditionally a lot in the past, but it's something that Sapphire don't advocate, mainly because of the risks, say, of spilling something from one balcony to the next and the nuisance that can cause to the residents. There's also strong evidence that continuous soffits greatly help resist the spread of fire, which is a subject of another CPD you may want to look at. But apart from that, the balconies with soffits tend to look aesthetically a lot more pleasing. So Sapphire offer two options here, generally. One where the water is collected and returned back towards the building to a small continuous gutter, which can then be diverted to a rainwater pipe. And the other, which is increasingly popular, is what's known as controlled drainage, where the water again percolates through the decking down to the soffit and is allowed to be dissipated via a gentle slope on the soffit out to the front edge, and allowed to drain off. Now, this is something that's been pioneered and pushed by Sapphire for some years now, and has become an accepted and well recognised method of dealing with water, particularly as Sapphire, as we'll go on to explain, segregate that soffit into smaller components to avoid any possibility of water congregation, which could cause a nuisance. The concept is being released in the new British standard, so nothing here we're saying is contrary to what's will be come out when that finally comes out. So the principle here can be seen by looking at these plans of balconies. A typical projecting balcony, the water flows directly away from the building. The trays on a Sapphire balcony are 400 millimeters wide, so the amount of water that can collect on any one tray is the same, irrespective of how long the balcony is. BS 8579 actually restricts the projection of the balcony to 2.5 meters when we're using this controlled drainage. But apart from that, it doesn't give any restrictions. Where a balcony is in an included corner or an inset balcony, as you can see there, it is important that the water is not allowed to dribble out onto the facade, because that might cause some pattern staining. So what we do there is the edge tray is canted so that the water is dispersed no nearer than 400 millimeters from the adjacent facade. So in that way, the water is allowed to dissipate and re-amalgamate with the rain that's coming down outside, just outside the balcony anyway, without causing any nuisance to the, or any damage to the facade. There's a couple of pictures here of projects I'll show you with this controlled drainage. Is a 30-story stack there in Islington. We've done some interesting experiments to monitor the amount of water that falls actually within the balcony, on the facade and externally, and use that in as part of our research in justifying this method of controlling the water. There's another picture here, a stack of vertical bar balconies. There you can see, and if you look closely at that picture, you can see underneath the balcony stack that the ground is actually dry. These are some examples of positive drainage before the downpipe's fitted, so you can see the outlet there. And this is a perfectly acceptable method if rainwater pipes are needed for draining the roof, for instance. It's quite easy to divert any rain from the balconies into a piped drainage system. But of course, that does need maintenance. It does can cause long-term blockages, and you're actually attracting the water back towards the building, whereas with a controlled drainage system, you're getting away from the building where it can cause any nuisance. We can also offer continuous guttering systems, so where you've got long walkway balustrades, or as you can see in this building here, the gutters can be linked end to end to form a continuous gutter. The regulation which covers gravity drainage buildings systems inside buildings is BSEN 12056, particularly Part 3, and there's a couple of clauses there we've just pulled out which gives some guidance. It speaks about the angle of the rain, which I've already covered, and particularly NC6 there, the tall buildings, where it clearly states that gutters and rainwater pipes may be omitted from tall structures where runoff would be dispersed before reaching the ground. So there's guidance there also on what rainfall intensities we should use when calculating these matters. But the basic concepts of rainwater drainage are covered quite adequately in approved document H, and I won't go over this in detail, but there's a number of clauses there and clear responses as to how these are met by the Sapphire system. The concept of controlled drainage comes under a a section of the document known as eavesdrop system, and you can see there some extracts from the notes and more detail, which is available on our website if you want to look into that in more detail. So on a project specific basis, Sapphire produce a water management strategy document on request, and this will look at each balcony in the building, look at its location in the site, look at what the drainage underneath the balcony stack is, and whether it's over private or public land, whether it's over principal entrances. There's a few areas where we will always recommend pipe drainage, but otherwise controlled drainage probably covers 90 to 95% of the balconies that we currently produce. So there's numerous projects that we've got from large to small that have already been approved by the NHBC. We have an type approval from Premier, who in conjunction with LHBC, and also we've had a number of successes in Ireland, Republic of Ireland, with Home Bond, and also, as I say, it's endorsed by the PSA 579 committee. So really, just in summary, the best way to drain the balcony is through the decking boards and into the soffit, and then to dissipate it and to drain the water away from the building. But the 6 square meter rule that many people still quote, just a reminder that that's really applicable to roofs and is really not applicable to projecting balconies. So thank you for listening to this short presentation. Trust that's been useful. There's certainly more details on our website, or you can attend one of our ResiBuild events or one of our many other CPDs on other related subjects.
Thank you, Andrew, for a very interesting CPD there. Again, if you'd like to ask Andrew any questions, please do enter them into the Slido link below, and I'll pose that to him during the Q&A session. I'd now like to introduce Archie O'Donnell. Archie's coming from i3PT, and he's going to be talking to us today about ensuring quality in Irish residential construction.
Welcome, Archie. Glad to have you on board. Tell us a bit about yourself and about i3PT and what you can offer the industry.
Yeah, my background is in low energy design, passive house, architectural technology, and sustainability. So i3PT certification, the name stands for independent third party tested. And you can see that was designed by, that's what happens when you let engineers design the company name. But it was formed in 2011 with the goal of becoming a certification system for critical building systems, you know, like your fire alarm, your building energy management system, your security system. And it was about making sure that, you know, where there was a very specific requirement for systems, that you had some kind of standard that they could be certified to. In 2014, a new building control regime came in, which was about making sure that buildings could reach a certain, could be certified by a third party as compliant with building regs. So i3PT started to work as technical oversight on projects in that role of assigned certifier. And we had to develop a methodology for doing that. And we found that, you know, there was a kind of a rigorous process that was put in place by a code of practice from the government. But we found that that was almost too linear, too specific, and it didn't really suit the types of buildings that we were seeing. And we found that it was better if we just focused towards quality. And we brought on a whole team. I was brought on for Part L and for energy efficiency, but we brought on fire engineers, structural engineers, architects, and then later we brought on building trades. And we very quickly began to figure out that there was a huge amount of information gets developed on a construction project, and we wanted to make sure that we could capture that efficiently and structure it in a way that it became usable. And that's when we started building our own digital platform, Search Central, and that was a quality assurance product. Now, we found after a year of developing this that it was trying to do too much. It was trying to capture every piece of information, and became very difficult for our users to keep up with the requests for information. So we decided to scrap that after a year, after a huge amount of development, and start again and try to make a system that was much more targeted towards what's important. Just want to say that the challenge we see coming ahead is there just isn't the number of trades out there, and that's why we're seeing an acceleration in the use of more sophisticated ways of building and more focus on manufacturing. And like yourselves, like Sapphire, you eliminate an awful lot of messy site trades and coordination and delays that could happen. But it's plug and play, and we're seeing that across a number of systems. So there's a number of drivers we're seeing, and the skills one is only one of those. And I think COVID has really accelerated that change. We're also seeing that the type of the market is looking for a different type of building than it would have been previously, and economically it's looking to build things quicker and sell it on quicker. But a big change for us here is the PRS market. We're seeing a huge amount of investment to build to rent schemes. So we've had recently a big investment in student accommodation and in build to rent apartments. And that side of the market takes a different approach. So it's a bit different to office blocks, commercial developments, pharmaceutical developments, in that there's a very kind of repeat pattern. That you have a standard solution, you execute that and repeat. So if we see any issues or mistakes, they're bound to be replicated. So the other drivers that are having an impact is, we're seeing the impact of the Grenfell inquiry, where facade systems have changed quite a bit. The materials that go into facades have changed, and we're also seeing big changes due to our enhanced energy standards. So nearly zero energy buildings also having an impact. But all of these are happening at the same time, and that's putting pressure on an already pressurized industry. And I suppose people now are looking at how do we react to the challenges that are ahead, and technology is just one of the tools that's being used. So we would see a move to more residential and build to rent schemes, skills shortage, huge pressure on fees, on programs, on the consultants to deliver fully coordinated designs before getting to site. And with a lot of the offsite systems like gauge steel or modular offsite, you can't leave anything to chance at site stage. Everything has to be done early doors. So MMC for us is a lot of the materials that are used for low energy. So the curtain walling systems, the precast systems, curtain walling, offsite, thick build systems. And a big challenge for us is just identifying who's actually keeping track of all of this on site, who's coordinating, who's watching for workmanship, who's making sure the right materials are used. And secondly, then, yeah.
Just going to say, sorry, is BIM a mandatory requirement at all in sites in Ireland? Because obviously BIM
it's not.
facilitates often.
It's not mandatory, and different clients will have different requirements for BIM.
Yeah.
For some of them, they want BIM at the end of the job to go into the facilities management file. For others, they want fully coordinated BIM. But generally, you would have the architects, the structural engineers engaged with BIM, but you may not have the fire engineers involved with it. It's actually what we find is the contractors are actually leading the charge towards BIM, because it gives them more control and more ability to see the problems coming down the tracks.
Yeah.
So I suppose there's different definitions of BIM, and for some it's all about the graphical information.
Model, yeah.
And we find that's a bit distracting, because you're looking at nice models, you're looking at pretty pictures, but we have a focus more towards information. What's more important to us is that the I in BIM is the important part to us. It's the information, that it's coordinated. So there's one single source of truth, and that it's tracked and it's managed and it's reports. So, we reluctantly got into BIM. We came to it quite late, and we thought that we were well behind the curve. And we used it just to manage our own information. Like we do quality assurance and regulatory compliance under the BCAR regime. We found that we were collecting a huge amount of documentation from a wide range of stakeholders. And we started to structure information, and we found some of the best structures were structures that were used in BIM, such as Uniclass classification and the naming formats in ISO 19650. And we just adopted those systems because they were lean and efficient and clear. And we found that we were actually ahead of the industry when we applied these. So I think a lot of the reasons for doing BIM should be down, the benefits should be down to individual companies, be that a supplier, a subcontractor. And it shouldn't really be something that's insisted on from the top down. And we found that some of the best companies we've worked with, they use BIM because it makes sense, not because they're told to. And so we're seeing a slow change in that. But for coordination, for management, and for letting the client understand the building they're purchasing, it's extremely useful.
Yeah.
So we put a lot of. Sorry, Nick.
So I'm just saying, for DFMA, the whole exchange of information and so on, and some of these, I was thinking of it in relation to light gauge steel and those sort of systems. Obviously, there's a lot of benefits to be had, particularly if you're building it in that method, isn't it?
There is, and we work on off-site constructions that are built all over the world, and with COVID, we couldn't travel to the factory to see prototypes. But we found that now through BIM, through technology, that everyone can see the building in minute detail. You can see the coordination. You can see the ownership. And for us, it's very important to see who's responsible for various components, and who's responsible for overlaps, who's looking for gaps, who's trying to see that the design is fully coordinated. We spend a lot of time mapping out responsibility, but we find that while it's easy enough to map responsibility and see who's taking responsibility, it's a bit more difficult to actually find out who's accountable. So people will take on responsibility, and then they'll shift responsibility, or they'll share responsibility. But ultimately, it comes down to who's accountable for this. And the Grenfell inquiry and the podcasts from the BBC, we learn a lot from that about what it looks like when you get building failures and people are held to account for their actions. That
Yeah.
they never knew that was their responsibility, or somebody else was in charge of that. So we spend a lot of time at the outset of the project making sure that everybody knows what they have to do, and that they have a clear set of requirements and deliverables. And where we work with offsite construction, we try and make sure that they understand that it's not just responsibility for design and execution in the factory. That product has to come to site, and somebody who understands that product has to be on site to see that it's executed correctly. And what we found with offsite is the quality management systems that come from the factories and come from those very sophisticated manufacturers are actually more advanced than what would be used on site. They have very clear and simple sets of deliverables and checklists that are needed at each stage. So we actually find that we can work quite well with the offsite construction teams. But where it gets difficult is integrating that with site practices. And some site practices are poor in terms of oversight and supervision. And I think that's a cultural change that the construction industry is dealing with. And for the last 6 years, we've had a kind of a change in regime in terms of building control, where the onus is very much on the owner and the owner's employees, the design team, and any third-party testers or inspectors to actually certify, that the building is fully compliant with regulations and with the relevant standards. So that has kind of focused the mind when people have to sign a cert to say that they have checked that it has been designed and executed in accordance with standards, with the design requirements, with the specification. You kind of have to spend a bit of time, reviewing shop drawings, visiting site, and checking interfaces, and checking downstream to see what impact one component can have on other dependent systems. So I suppose as the market moves more to design for manufacturing, it's not just about leveraging the new technologies, but it's about actually understanding the importance of people and people's culture. Like, we all have our own biases.
Yeah.
Everybody goes to work to do a good job, but when we're under pressure, we find it difficult to prioritize certain things that are important. And I think what we've spent a lot of time on doing is mapping that out and giving people simple, clear deliverables that, this week we want you to go to level 4 and check that all the brackets are torqued, or check that horizontal fire barriers are in at a certain level, and that they are exactly as per the installation in their fire test that was conducted in Warrington. So that it matches specifically the performance requirements of that product. And I think once people know what's expected, once it's laid out clearly of what's expected, I think people rise to that. So that we have seen a much more sophisticated, professional group of subcontractors and specialists and contractors and site engineers now than when we went through this volume back in 2000.
Yeah.
So for us, we're a building certification body, and I suppose we manage the certification of buildings and the inspection on site of buildings. And before tender, we get involved, we review designs, and we challenge the design team about detailing, coordination, compliance. And we build an inspection plan. So we try and map out what success looks like in terms of quality for the delivered product, for the delivered building. And we have a kind of an inspection and test plan that involves not only the design team, but also the contractor, the subcontractor, the specialists, the testers. And that creates a lot of documents, inspection reports, open issues, design reviews. There's a lot of documents, and they're managed in our data platform, Search Central. And initially, this was something that we just had in-house for ourselves for quality audits, but now we share it with the entire design team, with the contractors. And lately, we've actually been licensing it as a standalone product. What we also do is we have a trades inspection team. So we have we're mostly architects and engineers within the certification side, but on the site side we also have mechanical and electrical and trades inspectors, and they go to site and they pick up quite a lot of issues related to workmanship. So I mean, they wouldn't have a background in understanding design coordination and dimensional requirements, but they know if something is fitted incorrectly. We also do defect management then. So a large part of what we do is identifying things that may be wrong or maybe work in progress or maybe needing further clarification, and we log those and we manage those centrally. So anyone who's on site or who's supervising or inspecting site, they can identify issues and keep them on a log. And some of them aren't really, they're not defects, they're just simply observations. But we can categorize them, and at the end of a project then we try and see that everything has been closed out. And the other thing we do then is we try and encourage the team members, on the contractor side and the subcontractors. We just push everyone towards a kind of a common understanding of quality, because quality can be quite nebulous, it can mean different things to different people. But we try and work out a way of making sure there's a shared vision of quality. And generally that's about, sitting down with each of the suppliers and subcontractors and engaging with them to see what their goals are towards quality and towards achieving compliance. And we anticipated when we started doing this that the subcontractors and contractors would push against this. They'd say, this adds another layer to an already complex process. But over the years, we've found that they become very engaged in this process, to the point where the contractors actually bring us on to their own design and build projects because they want that clarity in terms of output. So how do we do that? How do you build a quality system then for a project that everyone can buy into? So we have the inspection and test plan. We set benchmarks then. So the first of a kind is very important. So the first benchmark we do is sets a yardstick for that particular work package. We, as mentioned, we track open issues. We have queries then, so we manage kind of conversations about quality, about observations, and then we collect critical documentation. So all those test results and certs and commissioning documents that are needed to say that the project can be handed over, we collect all those, we track those. So like for our clients, a lot of our clients are investment firms, or they're developers, or they're large blue chip companies, and risk is very important to them. They're quite risk averse, so they like this idea of independent oversight. So they like to have someone on the project who's rigorously inspecting and checking for those risk issues. So when we work across 250 projects, we know the issues that are likely to arise in any particular project, and we try and cut those out from an early stage. We've built up our own culture of compliance where we want to work with other members of the construction team, and not in an adversarial way. We're not building control. We embed ourselves within the project, and we say that our best outcomes are the team's best outcomes. and we work with them. We will allow the specialists and the subcontractors to tell us what a good quality outcome is, and we roll in behind that. We have our own facades engineers, sustainability engineers, health and safety, fire engineers. So we're like an extra layer of oversight on the project that just picks up those things that can get missed in a standard design build process. And record keeping, then we just make sure that everyone understands what they're responsible for, and try and set a clear list of mandatory requirements that they should hit. So what we're trying to do overall is kind of reduce the likelihood of failures in the building process, and just make sure then that that the technology makes it simpler for everybody to understand what their duties and their responsibilities are, and make sure we then take the position that we become the accountable party to make sure that everything is collected and certified. So we will look at right up the supply chain. We will look at the handrail designer, the lift subcontractor. We'll bring everyone into the process and try and make that as simple as possible. And what we want to see is that across all the project, there's transparency, accountability, and we really want to improve site cultures to make sure that we get the best of everyone's nature. That behaviours are all focused towards quality outcomes, and that there's a record trail then of all of that good work. So we have a cost model for that, but for Cert Central, we're either providing a service, or else we're providing a software. Now, within the Irish market, I suppose we had our own high-profile building failures. They weren't as catastrophic as Grenfell. It was apartment buildings that were, I suppose, hastily built and not with the best oversight, best materials. And we're still seeing that legacy in Ireland. There's quite a number of apartment blocks where they've lost a huge amount of value because they don't have a valid fire certificate. They're not. The fire brigade have done inspections and have said that it's not habitable, so they're getting rectified at a huge cost to the owners. And unluckily enough, my wife and one of her friends bought an apartment years back, and they're going through those issues, and there's no remedy for them. But the system that was put in place to deal with that is this Building Control Amendment Act, and that has placed the responsibility on the developer or the investor, the owner of the building, the beneficial owner at the time of construction, and then appoints statutory roles. So you have an assigned certifier, who can be the lead member of the design team, or can be an external party, and you have a design certifier then, who's the lead designer. Again, that can be another third party. But the certs that are signed by the statutory parties are quite explicit in how they set out the responsibilities, the accountabilities of those parties. But all other parties that either design or execute have to sign another form of cert called an ancillary cert. And that ancillary cert isn't a statutory role, but it does sign that an individual has taken accountability for their responsibility, their area of responsibility. And behind all that is a whole series of reports and documents and evidence of site inspection. So it creates a huge amount of documentation and coordination, and that's what we track. It's been referred to in the Hackett report as the golden thread. So it's all that supervision and quality management documentation. And that includes design reviews, such as shop drawings being reviewed by the lead design, site inspections where they involve specialists. Like we would often get fire damper suppliers to attend a benchmark, and we have we use mobile technology, so mobile QA tools for site inspections. And what we're aiming towards is that there's one single source of truth for the project, that you just, in terms of reviewing quality, you just go to one place, and the design, the site inspections, the live document specification, drawings, technical submittals, they're all in one place and they're easy to search. So if you're up on a mast climber on the 15th floor of an office block and you need to get a data sheet for a curtain wall, you just search for it and you pull it up on your, on your iPhone or your Android. And this covers all the various elements that are part of a quality system. I suppose when we started off looking at how do you build a quality system for construction, it was said, well, you can't apply kind of factory or industrial type quality processes to a site. It's outdoors. You have a very diverse skills base. A lot of them are individual subcontractors. They keep all their records on the dashboard of their van. There's all these arguments, but we found that you can actually apply, a very rigorous inspection, quality management, reporting system. You just need to give people the information in a timely fashion. You need to make it as simple and intuitive. So, we would say, rather than give someone an entire quality plan and tell them to read that and come back with their own system, we sit down with them and build it for them. So we say, look, at these key points in the project, we want you to do a site walk down and report. We want you to, show us that your technical documentation has been reviewed. If you have something complex that interfaces with a lot of other components, we want you to organize a benchmark for that. So we focus on the complexity, we focus on the high risk elements, and the rest of the stuff we will get anyway. So it's kind of proportional, and that's what we find with modern methods of construction and design for manufacturing, that they're quite complex systems, and the lead designer isn't expected to be an expert in that area. But within the overall team, there are people who are, subject matter experts who've years of experience. They know all the nuances of a particular system, and they're the people we want to bring into the system. So the person that will tell us that, a helping hand bracket or a thermal brake is installed correctly isn't often the engineer or the architect. It's often the supplier or the fabricator. And so we make sure that they're brought into the process, and we'll ask them, what are the key checks you need to know that this is right? How do you tighten the bolts around this? What tolerance should you allow for? What are the conditions that this has to be fitted in? And it becomes then about, when we talk about quality, it's about those things that an expert in that subject would know to look for. So those key indicators that tell you that everything is all right. Okay.
Yeah, that makes a lot of sense. So you've approached it from a point of view that you've had this experience from the sort of clerk of work side of things, and you're taking you're not a software company coming into the construction industry, as if you like. You're on the feet on the ground construction company who are making a collaborative platform, if you like, for taking forward that management and collating all those quality standards and for the project and what needs to be delivered.
Yeah, we've had to build this from the ground up, because when the building control regime came into place, nobody quite knew how it would turn out. There was some kind of simplified processes to do this, but it didn't match what we were signing at the end of the day. We were signing a document that said you need to know with some certainty that this building has been built in accordance with, regulations, standards. And regulations is often difficult. Like, we've certified buildings that were actually designed to go on fire. We have buildings that, are enormous buildings that don't have people in them. And trying to fit those into the regulations is quite difficult. So we had to go away and kind of look at this from an outcome point of view. Like, what, at the end of the day, if we want to say that this building is built in accordance with the functional requirements of the building regs, and it's a building that's safe to operate, how do we say that? How do we get to that? And we found that, you can build it from an outcome, but in order to know what those outcomes are, you need to engage with those people that know the buildings, that know the systems, and we bring them on board, and they become the people that educate us. So we don't like to talk down to people, and we learn from the people who are the subject matter experts. And a good block layer knows their system, and we ask them what's important about this, what mix is important, what tolerance, what kind of expansion joints, and they'll tell us that. So often we can build a more sophisticated system by talking to the suppliers, the subcontractors, the fabricators, the specialists, than actually looking at the regulations or looking at the international standards. But it's, every day is a school day. It's actually quite exciting that, we get to see so many different types of buildings, so many different types of construction. And, the toolkits that people have in terms of the products and systems they can use, like just going to a factory that builds light gauge steel houses and seeing the skip outside and seeing maybe short pieces of metal in it and saying that's a week's waste is phenomenal in terms of sustainability. Or
absolutely,
just watching modular volumes drop into place and a day later being plugged in and operating as a switch drum. It's a really exciting time for modular, and this whole plug and play and the Internet of Things. It's getting to the points where our buildings are becoming the machines that Corbusier talked about, but they're also becoming more comfortable, that you can accurately predict how a building will perform, and then you can measure that to check that it lives up to its expectations. So the technology is interesting. The fabrication is fascinating, but people are still the same. People need to be motivated. They need to be given clear direction. They need to understand what everybody is working towards, and that's what keeps us going every day. That we want to build systems that help people build better buildings. And buildings that we kind of ask ourselves sometimes when we have difficult compliance questions. We say, well, if I was getting this built for myself, or if my daughter was moving into an apartment, what would I want to see in that apartment, or what would I want in that building if it was my own building? And that's really the outcome that's important. But I do think that everyone we encounter, when we get to talk about what's important, we're not, collecting certs. We're not pushing paper trails. We're trying to find out, if you were to tell us that you've done your job in the best way possible, the job that you were pride in, what are the things that we need to learn from you about what's important put into our document system, into our inspection records, and it's that human interaction that's important. Like, you can have dashboards, you can have analytics and documents, and buildings that are fully connected, But what we really want is the individual on the tools, or the engineer that's walking down, signing off on a project. We want them to tell us that they have actually, done a fairly rigorous due diligence. They have collected all the information that tells them that this is a job well done.
Yeah.
And the best ways we found to do that is, everyone carries a camera, a computer, a microphone, a GSM in their pocket, and it becomes quite easy, now to be able to, to do a quality assurance audit of a particular system, and the job hands, or the foreman, the site engineers, they can walk down a system, every Friday, walk down the ventilation system first fix and make observations. So it becomes easy to actually produce really detailed records just by dropping a pin and taking a picture and writing a few notes.
Yeah.
So we do that. We do all that on, on tablets and iPhones, and we're on Android as well. So it becomes easy then for the building owner, the contractor, the design team to talk about quality. It becomes less of a subjective thing, and it becomes about the metrics. So everybody can see that as it reaches completion, that certain things can be closed off, can be addressed. And at any point in time, you have a live dashboard that tells you the status of quality, and any observations or issues that have been identified have been closed or are on their way to being closed and are in the review stage. And I think being able to have everyone communicate, the status of deliverables is quite useful, in that, it's quite easy to see at a glance if things are getting out of control, if there's a problem, if there's issues. And we found that we've put all of our tasks and minutes onto this platform. So, if someone has a lot of actions, they can see that on the dashboard. Once they open up this system, it'll tell them that they have, 4 meeting tasks, they have 2 site inspection reports, and 3 open issues to close out in the next fortnight. And just, allows people to manage their workload that way. And we've I was going to say digitized, but our head of digital calls it digitalization. But it's not just about turning paper into pixels. It's about actually changing a process to make it work better online and in the cloud. And we found that meetings, a lot of stuff got put down on paper with tasks and deliverables, and every meeting was like Groundhog Day. But we found that once you put it into people's task list, that it just becomes there as another action they can tick off, and you get a bit of satisfaction out of, reducing your task list and keeping on top of things. And it's often, if you go to a meeting and the client has flown in from overseas, they'll often, in the taxi from the airport to the site meeting, they'll open up Search Central and they'll see who's behind on the homework, and then they get their insight into the project that way by looking at the dashboards and the metrics. So there's, nobody wants to be the person at that meeting that is behind on their actions or tasks. So it's a good motivator to get people to stay on top of deliverables. And if someone is getting tasks that aren't really for them, they can simply respond to that and push it out date-wise, or pass it on to a team member, or else just categorize it that it's not relevant to them. So it's an easy system to manage.
So the approach you're the approach you're taking with this, and I'm assuming you're normally appointed, are you, for the clerk of works and for managing this whole process, and the client is feeding into it from one hand, but you're managing that process, and then you're working with other people. The people on the ground on site might actually be other people doing the inspections, like our balcony installers, for instance, feeding into this process, and you're kind of managing the whole process in this tool. Is that correct?
That is, like, we worked with your balcony designers at the start, and they sent us all their calculations and tech subs, and we made sure that the design team had oversight of that, and any comments came back. And you know, your own designers engaged quite well with us, and they mentioned what were the key components that needed to be checked on site, and what was the process, and that all fed in. And then we determined that at site stage that there would be a representative from your company that would come to site and would ensure that tolerances and fitting was all correct. So it was about just setting out those requirements early in the project. As soon as a supplier had been identified, we wanted to check that they understood the local standards and the specification requirements, and then made sure that, you know, with some products they're dropped on the site and there's no engagement from the supplier. But, you know, with the more sophisticated systems, we're finding that the supplier wants to take ownership of that product, even at site stage. They want to ensure that it's done correctly, and, you know, where a system has a warranty as well, that you know, there is a need to make sure that it's checked. So you know, we are seeing that with you know, those sophisticated off-site systems, and with, you know, specialist products that it's not just a design, it's not just an install, but it's giving the whole picture. They're certifying their system, but within the context of the overall building certification. So it makes sure, you know, if there's a fire cavity barrier that runs through a balcony installation, that's coordinating the design, and then it's clear who has responsibility for checking for that. And, you know, on another building, you know, your designers had liaised with the sustainable drainage designers to make sure that they were looking at the downstream impacts and all that. So it's I suppose the approved inspector in the UK is a very external role, but we found to deliver the role, the building control role, of the third-party building control certifier. We found in Ireland you've actually had to embed yourself in the process and actually become affiliated with the entire supply chain, because, you know, you don't actually know where issues will arise. You can do a risk review of that, but you need to ensure that if there's some very specialist works going on, that they're brought into the process, and that you know, you're not leaving any gaps in the process, but that there's no overlaps. It's actually the overlaps that give us most concern. You know, where you have an interface between curtain walling and rain screen, we want to make sure, well, who's actually taking responsibility for the waterproofing between those two systems. You know, how is the expansion dealt with? How is drainage dealt with at that interface? So it's about creating a full ecosystem, a full compliance picture that encapsulates the whole project and all of those external parties and supply chain. And, you know, and that does come down to you know, connecting with them digitally, but also connecting with them at a human scale. You know, so it feeds back into, you know, how do you have a system that deals with just those changes that we're seeing in construction, those changes from you know, from move towards offsite, from a skills shortage point of view, and from a you know, from design design teams and design delivery that's very different to the traditional. It's a very dispersed design process, very different contractual process where there's more reliance on design and build and design responsibility by main contractor. So it's finding out what's a common process, what's an approach that suits the majority of construction projects, and that's what we've been building. But I think out there in the construction industry, there is more use of BIM, there's more use of quality assurance, there's more use of common data environments. What we've ended up doing almost by default is pushing them all into one system, so you get it all in one place. So and keeping that in the cloud, so it's a communication tool. But as we will see big changes in construction in the type of systems and products that are used in building to get efficiency, to get better environmental sustainability standards, to get projects moving quicker, and to utilize the technology that has been used in other systems. The construction industry, I think, is probably the last really to automate its processes and go digital. But that's really accelerating in the last few years, and COVID has really been a catalyst for ensuring that happens quicker. And we can't be on top of it all. But we have to make sure that we have a process that's in place to be able to anticipate what's coming down the line. That skills shortage, move to offsite, different materials, higher risk. The more sophisticated clients. They're all drivers that start to push us towards. Having very transparent, open, shared platforms for managing accountability, quality assurance, information management, and facilities management. And we believe we're trying to anticipate where the industry is going. Okay. Question?
One of the key things which I'm picking up here is obviously the reason people are embracing this for a start is predominantly risk-based, whether that be risk of building a building which ultimately needs to be changed, or whether the one end of the scale, you got the tragic events like Grenfell, but the other risks is the risk of having issues during the construction phase which push off the program and so on. But I'm getting kind of three main parts to this from as you're speaking, Archie. One is about for the success factors. One is, it sounds like, it's clarifying the standards early, getting expert advice in the particular field so that it's actually intelligent in what it's asking for, and making sure that it makes sense for all. So it is their role, and you can see it clearly, and you can see where their piece fits into the overall picture. Are they the kind of the three main things, or is there other foundational things you think which are quite key in getting this whole piece of work which you're working towards right?
No, that's great. I mean, I should use that as an elevator pitch, but it is, and it's about kind of offsetting the those risks. The three main risks is kind of the risk of defects, delays, and disputes. And it's about just bringing everything into the open early on and deciding, well, what does success look like? Success in terms of building quality, in terms of making sure that at the end of a project, everyone is clear on what's needed, and making sure that the building that's delivered is the building that was designed, that was specified, that has met those performance requirements. And I mean, the way to do that is just to engage early with all of the relevant parties, but continue to I suppose, communicate with all the relevant parties and to challenge people to say, well, you know, what are the expectations in terms of quality, in terms of what do you need to see, you know, what needs to be checked. And it starts very high level with applying the regulations. But, you know, the regulations are the bare minimum. They're not a target. They're just the bare minimum that must be met by suppliers and designers and contractors. But we also say, well, what are your own industry standards? And beyond that, what are your own standards in your own company? Like what are the installer requirements, or what's your own QA system? You know, and a lot of the suppliers will have very detailed checklists themselves. They'll have very precise installation instructions, like anything that needs to be fire tested. You know, like for instance, fire doors. They're very specific on where screws must go, how hinges must be located. So you know, we have to bring those people into the process, and it is about collaboration. But often collaboration was thought, well, it's just the lead designers, it's just the main contractor, but it's not. The most important people are, you know, those kind of external designers that are within the supply chain, that are, you know, some of the guys that are and girls that are on the tools, you know. So it's that entire ecosystem, and it's making sure that, you know, that we can identify where the risks are, even if they're not within the core, they're not the usual subjects, and you know, because of that, I suppose the change in the skills market, because, you know, we have new products and materials and new ways of interfacing and connecting building materials. We need to look at this a different way and look at a much broader, diverse market, and more diverse project team. And, you know, having a cloud-based management system allows us to bring all that in easier. And then, you know, we have one project that has pre-made components, you know, modular rooms that come from the US. It has plant rooms that come from Singapore, you know, and it's very diverse. And trying to map out who's the responsible designer, who's commissioned each of the systems, who's made sure that, you know, the cause and effect between the systems and the passive fire protection, that has been checked and tested. It becomes very, very complex. But if you map it out early in the project, it can really help. And where this becomes important is, you know, 10 or 15 years down the line, if the building as an asset is being sold or transferred, that you still have this package of information that is still a live package of information, in which you can see how that product has been installed, how it's being maintained, what its service life is. So you can manage a project from cradle to grave, and you know, it becomes that digital twin of the building. That, you know, the building is an intelligent system that needs, you know, that has to be constantly updated and kept live. And we find if you start early at the construction stage and get all the relevant information and have it reviewed, make sure all the necessary tests and checks are done, that you start off in a good place. And the owner of the building then becomes the owner of all that useful information. Okay.
Yeah, so it's interesting that we've talked around a few different things. We talked around BIM, around DFMA. We've talked about MMC. They're obviously buzzwords in their own right, but ultimately, what we're talking about in terms of the problems which all of those are aiming to solve, they're actually relatively similar. There's the labour shortage. We've got the improving the quality or putting another way, removing the quality risk, if you like. So actually, it's quite exciting, I think, for people like ourselves, which specialise in manufacturing properly MMC systems and so on, because we thoroughly believe in implementing good practices in the factory and reducing the amount of labour and cutting down the timescales and so on. But they all work hand in glove together. So the adopting of things like MMC or other areas like that is made a lot easier when there's a clear structure of the way you're capturing that information and the way you're collaborating early and actually starting off with the standard and the end in mind, if you like. Any comments on that? Is that how do you see this all fitting together for the Irish marketplace?
I think so, and it's like you made a comment there that within your own factory that you have very very rigorous quality systems and checks, and we would have seen that in say the precast concrete industry back 10 years ago, but when it came to site, all that paperwork and all those checks they didn't continue. So I think it's really about making the construction site a little bit more like the factory in terms of quality assurance, and that was our challenge. In that, it was said that you can't really apply that kind of quality standard to a building site because it doesn't have a roof over it. People don't clock in and clock out. We don't know who's there any particular day. But we found that there is a way. You just give people autonomy. You trust in people. You give them the tools, and you maintain a high level of oversight and communication on that process. And it's really then becomes about the outcome. That it's not a tick box exercise. It's saying, it's saying that together we will build a good picture of compliance and quality and make sure that we've met all the regulations, that we've applied all the standards, that all the tests have been conducted, and that the people who know what a system correctly installed look like, that they've been out and they've walked around and they've checked it. Yeah. So we have checklists where people can import their own checklists and go around and check the building. Or they can do their own observations. They can walk around and check and drop pins where they see things that have remedial actions. But it still comes down to it that with the best software in the world, you're still going to get issues with the best inspectors in the world, with the best quality audits in the world. If that information doesn't know where it's supposed to go, it's useless. So, we've tried to combine a service and a software. And, the service is about getting expertise into the field, and the software is about making sure that, all that information becomes relevant, that it's targeted, that it's distilled down to what's important, what people need to know. There's a huge amount of information, but we only tell people what they actually need to know in that particular week. And I suppose we've all got hundreds of logins for different systems. We've got notifications coming on our watch, our phone, our tablet, our computer, everything. And it all becomes a lot of noise. And what we've tried to say is, look, let's just distill this down to what's relevant for you, what you need to know to do your work. You don't want to spend your whole time, in front of the screen, uploading, documenting, and it's to try and make it lean and simple. And I mean, that's really the cultural change, is to make sure that it's not just the information managers that are sitting at a desk that are going to give us the information. It's the guy who's only on site for one day every 2 weeks. How do we make it simple for him? We've had people who say, well, I've never done a report. I've never uploaded a checklist. put photographs together and walked down the system and done a benchmark. And we say, well, what to use your phone for? And they tell you that they've uploaded videos to TikTok, or they've done Zoom calls. They say, well, this is easier than all that. You simply just walk around and drop a pin wherever you see good workmanship. If you have any comments or observations, drop another type of pin. And then before you leave site, just hit upload or save it as a draft, and it's done. And if you do that every 2 weeks, if you spend 15 minutes doing that every 2 weeks, by the end of the project, you'll have a huge repository of information that shows that you've been checking things on site. So it's small little pieces of a big jigsaw that start to fit together to build that overall picture of compliance. And there's a huge amount of information structure and modeling and data behind all that, but you don't need to know all that. You don't need to. You just need to know that what you're good at, or what your supervisor or foreman need to see, needs to be recorded. And if we have found that at the end of a project, if there's any disputes, there's any issues, people will go back through the photographic records and show, look, I did, before that wall closed up, I did make sure that the brackets were fitted on the pipe collars. So it's at the start of a project, people will say, oh no, not another data system, not another upload. But at the end of the project, people are saying, I hope you're on the next project. So it has been, you made a good point there, that it's actually been built by people who are in construction. It's not built by software people. It's the software people have been very helpful and useful and all that, but this is about working for us that are on sites every day, or have a background in design, or for our trades team who have a background in installing and fitting.
So, what would you say the key takeaway would be for or one key point you'd like to make to the audience about implementing this? What is the success, do you think, or the main purpose somebody might buy into this?
I think it's collaboration, and we've collaborated with Sapphire, and I think there was a mutual respect there that we knew you guys were the best at what you do, and you were very free with your information, and you were able to tell us what were the things that you worry about at night time, and it was very open and transparent and clear, and that communication was very useful. And in the end, the software is really just a communication tool, that it just collects a record of decisions. It's that golden thread of, why did we do it this way? Or when we should have checked the structural connections were going to work with the type of primary frame, did we do that correctly? So that due diligence was checked. So that really comes down to that relationship between. It's not a hierarchy. It's a shared narrative. That the main thing for us is that we work towards an objective, and that objective is the best possible outcome in terms of building quality, and everybody benefits from that. And it's that communication tool that lets us freely and without any kind of bias talk about quality, and without agendas, make sure that everybody knows what's expected of them. And that's a two-way thing, that we have a duty to the client, but we also have a duty towards the subcontractors, the suppliers, and any other stakeholders that the building is inspected and certified as fit for purpose. Okay.
It's great.
No, thanks for taking the time to understand what we're trying to do, and I think what we're doing fits in with your own culture. So and with a lot of the contractors, suppliers, designers, they all have this same culture that we find. And it's about just making sure that, that everyone it's providing a platform to make sure that we can all work towards those common goals.
Yeah. But thanks very much for your time on this.
Thank you, Archie. Very interesting topic, that one. Again, if you have any questions, please do slide down to the Slido and we can put those questions to him at 1 p.m. today. I'd now like to introduce Richard McMullen. Richard's going to be talking about Class A decking, and he's from MyDeck.
Hello and welcome. Thanks for joining us for today's presentation on the essentials of safe balcony decking. My name is Richard McMullen, and I'm just going to talk about some of the important features of why balcony design is essential in considering the materials that we use to try and prohibit or limit the spread of fire on the outside of a building. So today we're going to have a bit of an introduction, a little bit about MyDeck, looking at why balcony design matters in limiting the spread of fire, the principal risks of fire. We'll look at the Euro class classification, EN 13501, and then we'll dive into the products and run through those and run through some of the testing procedures that MyDeck puts their products through to ensure we deliver a safe, smart and sustainable solution. So at MyDeck, we're committed to a safer future. We have a simple philosophy: safe, smart and sustainable. Our mission is to enhance the safety of the apartment community through safe, smart and sustainable products and innovation. It's important to note that following the Grenfell Tower disaster in the UK, there have been a number of significant fires that had nothing to do with the combustibility of the cladding on the building, but simply to do with the design of the balconies themselves. The materials that were used in construction were combustible, and when there was a fire that broke out, the materials themselves contributed to the significant spread of fire. And it's one of these reasons why we've introduced the non-combustible decking system to the market. The aftermath of a balcony fire can be devastating. And you can see here a picture of a balcony in Dublin which caught fire. And you can see that the design of it was such that it had a steel outer frame, but a timber carcass. So the joists and subframe and the decking itself was all made from timber, and the results are devastating. So today we're trying to promote awareness of this and encourage a safer use of materials, non-combustible materials, in our balcony design and decking. So let's look at the key challenges of fire. Three key things which we really need to bear in mind when we're selecting materials in the construction process. Will the materials that we use create and intensify heat through burning, which will contribute to the spread of fire? If they catch fire, will they emit toxic smoke, which will further endanger the lives of people within the building? And another feature, which we often don't think about, is will they form burning molten droplets, which will increase the spread of fire again as they fall from the structure. So let's look at the Euro class classification, EN 13501. It has 7 classifications, starting with A or A1 and going through to F. So F are for products that have shown no performance criteria and they've got no resistance to ignitability and spread of fire. So steer clear of those ones. But today we're going to be looking at or focusing on the A1 and A2 products. The Euro class system, as we've just seen, has 7 classifications from A1 to F. And they look at various different features in the testing process. So they compare or measure the ignitability, the spread of flame, the amount of heat that's released, the amount of smoke that's produced, and then whether there's any propensity for producing flaming, burning droplets or particles. The standard is accepted by all EU states, and it is a harmonised standard. This means that the testing protocol is the same in any country, any EU country. So if wherever a product is tested in the EU to the EN class 13501, that testing standard will be the same. And the standard we want to try and achieve with the materials that we're using is to achieve an A1 or A2. So the legislation or the standard states that products achieving A1 and A2 classification are defined as non-combustible. So what does A2 mean? So in the UK, we have a standard which has to be achieved, which is A2 S1 D0. And this is a well-known phrase in the construction industry and those dealing with external facades in today's construction world. So A2 looks at how quickly the product will catch fire, how much heat it's released, and then how much the flame spreads. So A means we want to get a very limited measure in all of these factors. S stands for smoke, and we want to get to little or ideally no smoke being emitted from the product in the presence of fire. And D stands for droplets, and we need to get to a 0 rating on those. So in the presence of fire, we want no flaming droplets coming off the material that we're talking about. I just included this slide just to break down and cover off some of the A-rated materials that are available. They're not available necessarily, they're not suitable for all applications, but just really to cover that off. So we've got things like expanded clay, perlite, mineral wool, cellular glass. Then you go to more your aggregate type materials, which includes concrete and fiber cement and lime and blast furnace slag and minerals. And then you've got your metals. So that's your iron, steel, copper, alloys, and aluminium, lead and zinc, etc. And then finally, you've got more your gypsum-based products, which include mortar, plaster, and then stone and glass and ceramics. Okay, so let's look at the Midex system. So the Midex product range is made from aluminium. Why do we use aluminium? Well, aluminium is a Class A material. It gives us that sustainable credential, which is part of our company philosophy. So it won't rot or rust, and it achieves a 60-year design life. The other thing we like about aluminium is that it's easily recycled. So it contributes to a low-cost life cycle. It's coatable in a wide range of colours. It's lightweight and it's easily handled. So there's some really great credentials to the material there. So the important part about the aluminium decking as such is the powder coating. And it's essential that we have a very, very high quality procedure to our powder coating to ensure the durability of its use as a decking material. So all our deck boards, when they come out of the extrusion line and before they're powder coated, they go through a minimum of what we call a 5-bath pre-treatment process. So in other words, they go into 5 separate tanks to ensure that the material is absolutely clean from any type of oxidization or dirt before the application of the powder. We coat to a QualiCoat standard, which is an internationally recognized production standard, and it provides us with an audit trail which gives us certification, etc., after every batch of production. And we follow our application process to give us what's known as the Florida 3-year UV test. So this is an advanced UV rating, which measures the fade, if you like, under accelerated UV. Most, just to put that in context, most cladding and guttering would be powder coated to a Florida 1-year test. So we've really upped the quality of the coating process. So we like to think that we do have the ultimate non-combustible decking system. Every element of the system is non-combustible. So from the boards to the end caps, to the pedestals, to the rails and the clips, and the screws that go into the clips, every part of that achieves a non-combustible rating of A2S1D0, or in the case of the pedestals, they're an A1 rating. We have a wide range of colours, but we've selected 6 as a standard palette, which seem to work very well for most colour schemes. But if you've got a scheme where you're working to a specific RAL colour that you wanted to try and match or complement, then by all means contact us, and we can ensure that that powder coating has got the fire rating. So it's important to note that of the system, it's the powder that would present any risk of combustibility. So that's why all our products have been certified, tested and certified in the UK to ensure that they achieve that A2S1D0 rating. I want to introduce a new product which we've just brought out, which is a 2-part board. It's our Delta board. This enables us to fix the boards directly to a steel balcony frame. It was something that was driven by the industry. A lot of balcony manufacturers were producing steel frame balconies, and then historically they would have put a timber or composite joist on the top. And this being able to fix through the base of the board means that they can eliminate the number of joists that they need, which reduces the cost and the labour in assembling a balcony and makes the whole thing more rigid and faster to install. So we've got 2 depths, a 20mm deep board and a 30. The 30mm board obviously goes on a wider span. We can get up to a 1200mm span with this board. That then means there's less material required for the subframe, which then overall reduces the cost per square metre. So this is how we can drive greater value for the customer into the project. So what I've got here is just an animation which shows the typical installation onto a steel frame balcony. So it is just illustrative, but there's your board. We then use a bimetal stainless steel screw that drives through into the steel, and we then tap in a capping strip over the top, so everything is concealed. This facility also gives us scope to be very smart with the way that we actually crane a balcony onto the building. It means that we can deck the entire balcony without leaving any gaps between the boards for crane lifting, because we can actually design the balcony to take a lifting eye that would fix in, so the whole balcony can be finished and then simply craned in to position. And then we've got no risk of anything falling through the balcony frame because of missing boards once it's installed. So operatives can then walk out onto the balcony deck, remove the lifting eyes, and simply knock in the capping strip. So it's very, very effective and is reducing the risk. So we've had a lot of nod of approval from companies like Lend-Lease for this methodology, because they're very, very pro anything that reduces risk on site. Job done. So that's the Delta board. Then the other board that we have is our Vista system and Innova system, which requires a separate clip. I've got another animation here. Sorry about the noise. I'll just turn the sound down. But what we have here is a separate subrail system. This is useful in some forms of balcony installation where they're using a pre-constructed steel frame onto the building rather than actually craning the balcony in. And they use a simple rail that bolts to that frame, and then we simply clip the boards down over the top. So this works very well too on a terrace application, so where you've got a concrete base or an inset balcony, this would be the principle that we would tend to use as well. So having a subrail with the fixing clips. which I'll illustrate on this next animation here. So this is going on to a roof terrace environment or an inset balcony environment where we've got our steel pedestals, which you simply set out the levels, and then the joist rail will clip into those. So one of the key things here is we've got very little in the way of mechanical fixings, screws and things. And when we're working on a waterproofed surface, this is very critical because it reduces the risk of puncturing the waterproofing. So you see it's a very simple click fit system. So just fast, simple and effective. With the end caps, to be honest, they're not usually used. They would really only be required where the ends of the boards are visible, and generally speaking, they're covered by the base of a balustrade or an wall of an inset terrace area. But they are available if required. So looking at the summary then, so the whole system is a completely Part B compliant non-combustible system. We have an extremely high performance coating. One of the things we also offer as part of our sustainability ethos is to ensure that every board on larger projects, we cut them to the length. So what we do is we extrude, cut and coat, which means that we're only supplying what's needed. It saves a lot of wastage. Scrap material on site. It also speeds up installation and saves labour time. We've got a 30-year warranty, and it's a fast fit system. And as I mentioned at the beginning, we've got a very flexible global supply chain. So we have production lines both in the UK and Spain, and also we're setting up a new one in Italy. So we've got a lot of flexibility there. The other thing I finally wanted to cover off really is just to talk you through some of the testing procedures that we use, just to demonstrate some of the methodology that we have and the rigorous testing that we put MyDeck products through. So the first is our load testing rig. So this is basically a hydraulic ram, and we can alter the span between the supports. And this is a 50x50mm pressure area, which we put into the middle of the board. And so we test the flex on all our boards. One of the key things about aluminium is that it's not actually going to break like a composite or a timber would. So a breaking strain test was very critical on wood plastic composites because it will suddenly snap, whereas aluminium will bend. And what we wanted to just test was the level of flex at what particular weight loads and spans. So looking at this slide here, you can see that we've applied a force in kilos down the left-hand side of that table, and the displacement or the level of bend right in the middle of the span underneath that hydraulic ram point. So you can see that we've tested it up to over 600 kilos, and on a 600mm span, we've got less than 11mm deflection in the board. So that demonstrates the flex of the board. Now that was on our lightest weight board, so that's our Innova product, and all our other boards would exceed that. And as I mentioned earlier, the Delta 30, which is a deeper board, we're comfortable with that kind of loading on a 1200 span, and you still wouldn't have anything like that amount of flex. The other test that we've done, and we had a lot of people raising concerns, so some of the typical questions we get is, we've got a powder-coated aluminium deck board, how's that going to wear? So we carried out an accelerated wear test, which is effectively a treaded boot on a ram, as you can see there, and a panel of the decking rotates underneath the boot, and the boot provides a scuffing action to simulate footfall. So this test applied was over 100,000 footfalls on a 2-day period. Now, we've worked out that you would, on a typical balcony, if you achieved 15,000 footfalls a year, that would be quite heavy wear, and you would not normally be wearing a heavy treaded boot like you can see there. You're more likely either in your socks or trainers or slippers. So you can see there from that photo, that was the panel where the boot went round in a circular motion. You can just about pick up the wear area on there, but it wasn't significant at all. And then the other thing that we did was to carry out a slip test rating before and after. So you can see that we've done a slip test in 4 directions, both wet and dry, and on the worn area and then on the original area. And then you can see that we have achieved a slip rating well in excess of the 36 pendulum test value that is required by the HSE to be regarded as safe. So that's just to answer a common question there. And then this was the rating afterwards. Still in the worn area, the lowest rating we achieved was 39. So we're still falling well within the safe zone. At Minec, we don't always just like to rely on the theory. Sometimes we like to also put things into a practical test. And we put a doormat panel on a building site for Berkeley Homes at Woodbury Down, where we've supplied a huge amount of decking now on that development. This panel sat at the base of their access ramp into the project office for about 7 months. And it had around about 60 people 4 times a day walking over it in gritty boots, gritty building site environment. And what happened at the end was there was some evidence, as you can see from that picture, of scratching, which you'd expect. But what we were looking for was there any loss of integrity of the quality of the powder coating adjacent to a scratch? And there was none at all. Berkeley Homes were staggered at the durability of the powder coating, and as ourselves were very reassured as to what our expectations were. So there's showing the location, and then that photo on the right-hand side was what it looked like after 7 months. It went from a period of May to December, so it had all weathers, wet and dry, dusty, and very gritty at all times. So I wanted to just finish up on that, really concluding with the safe, smart, sustainable reinforcement of that message again, and our mission to contribute to the safety of high-rise buildings. I would now like to open the floor. Who's got the first question? If you've got a question, please don't forget to, please unmute and launch in.
Have you tested them dragging furniture over them? Most people would have tables and chairs, etc., on a balcony, which would be dragged all over the place. How do they stand up to that type of wear and tear?
Yeah, that's a great, thanks Helen, that's a great question. Yes, I should have included that. We do have what's called the furniture leg test, which is the brass point that goes across the surface, and that left virtually no trace of any damage at all. Now, that said, if people have got metal foot furniture on there and they do drag it or scuff it, the potential is that it could scratch. But it is a highly durable coating, and our testing showed that it resisted that damage very, very well. Another common question that we get is, does aluminium decking get hot underfoot? So whether, like we've got right at the moment, is somebody going to walk out on their balcony in bare feet and scorch the sole of their foot, scorch their skin? The answer is no. Aluminium actually is a massive heat conductor, and it acts like a heat sink. So aluminium takes a huge amount of heat to keep it hot, but the design of the board is such that it actually transfers that heat away from the decking surface. The example I give people is, if you imagine having a piece of tin foil in your oven, you can put tin foil in your oven at 250 degrees. You can open your oven door and take that aluminium out with your bare hands, and it won't burn you. It disperses heat very, very quickly. We carried out some tests last year compared with composite, and composite actually stays hotter, gets hotter and stays hotter than aluminium does. So you may often get clients raising that question with you, but you can answer with confidence that no, it actually maintains a lower surface temperature than typically the plastic composite materials do.
Richard, with the concealed fixing one in particular, where you were showing those hexagon-headed screws in the concealed recess, how much is expansion of each individual plank a problem? Thermal expansion.
Yeah, that's a great question too. That's Keith, is it?
Yeah.
Yeah. Aluminium expands at around about 1 millimeter per linear meter. And what we find is when we're on the metal frames, the coefficient difference between steel and aluminium is very small in the applications that we're looking at. So, and when you look at it in terms of a span, it's a fraction of a millimeter and the whole thing will just move. If it was considered a concern, then all that would need to be done is to make sure that we use a screw that's got like a wing head that drills a slightly bigger hole through the aluminium, and then when it hits the steel, those wings snap off and then go into the steel. So you actually create a little bit of expansion room within each hole itself.
Right, thank you.
Any more questions? Jack, has it all come through clear?
Yes, yeah, very good.
Does anybody have any concerns or something that would kind of, what I'd like you to do is to feel confident that by the end of this session of knowing what makes a good product and how to specify, and obviously to be confident in specifying my deck.
Compare price-wise with other decking systems.
So are you thinking of typically composite and timber?
Yes.
Yeah. So a typical aluminium deck now, so if I just took, for example, our Delta 20 board, with that product, you're looking at around about 80 to 90 pounds a square meter, just as a guide. Obviously on quantity, it can come down lower than that. Composite decking had quite a wide range of pricing. I think the lowest I've known it to be is around about £35 a square metre. That would be for quite a low cost economy product. I used to be involved in selling a composite decking that was more like £100 a square metre. So aluminium's slightly higher, it has a longer life, but obviously it's the non-combustible. With hardwood timbers, with some of the typical tropical hardwoods, you would be looking at around about 80 to 90 pound a square metre for some of those types of products as well. Excellent. If you use our website, you can go onto the resources page. There is a huge amount of resource there to enable you and help you in specification. So you can find us on NBS. We have CAD files and BIM families all available too. So if you need any help with specification, then please don't hesitate to contact us. We're very proud of the level of support that we can give in terms of design and technical advice. The other thing is that if you ever get involved in any refurbishment projects, we are working on a unique access system which will enable us to scale high-rise buildings of existing balcony stacks without having to scaffold or go through the buildings. So that's been proof of a lot of interest to housing associations and developers. We're working with a number of those. It reduces a huge amount of the cost and the logistics of refurbishing balconies. Does anyone have any more questions?
I think that's great. Thank you. Thank you, Richard.
Great. No, well, thank you for joining us today. It's been a pleasure, and I hope that's been of value to you. And Struan will be in touch. We'll issue you your certificates for each of you who have attended, and we'll look forward to working with you in the future.
Thank you, Richard. Again, if you have any questions for Richard, please do go to the Slido link and post your questions there. I'd now like to introduce Derek Russell. Derek's joining us from TechCrete, and he's going to be talking about quality facades for Irish residential construction.
Founded in 1985, TechCrete expanded through acquiring and developing the crafts and skills of long-established precasting companies, such as Rowcrete in Ireland, Empire Stone and Luda Products in the UK. In 1995, we acquired a UK manufacturing base at Brigg in North Lincolnshire, and in 1999, a new drawing office was opened in Leicester to supplement the design work undertaken in Dublin. TechCrete is one of the largest companies in the design, manufacture and supply of architectural precast cladding to the UK and Irish construction markets. TechCrete currently have 4 offices which can be found in Ireland and the United Kingdom. 2 offices are highly equipped to manufacture bespoke architectural precast concrete cladding. All 4 offices offer design services and excellent customer service through an extremely knowledgeable and helpful team. We are dedicated to building relationships through respect of all people, their cultures, their understandings and beliefs. We are considerate to the needs and requirements of people who may be affected by our business activities. We lead by example and work together to leave a positive impact through our actions and behaviours. Everyone at TechCrete has a role to bring about continuous improvements in health and safety performance. For this to become a reality, each employee within the health and safety system has to understand their role and perform their responsibilities. We believe that all accidents and incidents are avoidable through effective hazard identification and active risk management. We are committed to protecting the health and safety of our employees and that of others who may be affected by our business activities. We believe that every employee has the right to work in an environment where risks to health and safety are properly controlled. Sustainability is increasingly important, especially in today's construction world. TechCrete are devoted to sustainability, providing customers with the information they need, focusing on how we can provide a low-carbon building. TechCrete promotes sustainability both in the design and function of the product and in the process used in manufacturing. TechCrete has invested heavily in energy-efficient and environmentally sustainable processes, equipment, workshops, office facilities, and management systems. TechCrete holds memberships in both the British and Irish precast associations. TechCrete is ISO 14001, ISO 9001, ISO 45001, and ISO 50001 certified and Achilles accredited. We are Agreement certified, OHSAS 18001 certified, AEO certified, CHAS certified, and BES 6001 certified. This certifies our responsible sourcing of construction products. All TechCrete panels carry the CE mark. The inherent properties of precast concrete make it the natural choice for achieving sustainability in modern buildings. For example, precast concrete cladding is locally manufactured, minimizing transport costs and waste. Most of our manufacturing waste is recycled. Our products have a high thermal mass, which enables components to absorb, store, and radiate heat. It allows for rapid construction with fewer trades on site. It is also durable, reusable, and low maintenance. In all, our sustainable building products reduce energy consumption and reduce the user's carbon footprint. TechCrete are continuously searching to create savings that can be passed on to our customers. Through our R&D program, we are continuing to discover better and more economical ways of producing the highest quality and most efficient precast cladding components. TechCrete has developed a fully integrated management system that links all aspects of our work, such as quality, safety, environment, energy and sustainability. Our technical ability has made us the preferred precast partner of many of the leading architectural and consulting engineering companies in Ireland and the UK. From tender to design to manufacture to installation on site, We are TechCrete.
Thank you to the audience for joining us today. Really excited to welcome Derek and Darren to speak with us today about precast panels and how there might be a benefit for them in Dublin. So I guess to start off then, Derek and Darren, if you want to introduce yourselves and your roles at TechCrete.
I'll go first. That's Darren Bryan, and I'm pre-construction manager for TechCrete for the UK and Ireland.
Derek Russell, I'm the head of engineering for TechCrete.
Good, thanks. So thanks for joining us today. Can you start off by talking us through why you think precast might be becoming popular over sort of traditional methods, and what advantages it might have over traditional RC frame, etc.?
Basically, what we see at the moment, what a lot of people come to us is for a lot of to do with the cost and the program reduction for architectural precast in lieu of traditional methods. The program, what do you call it, for panels, we can make panels up to maybe possibly 20 square meters. So if you look at that, we get probably 5 of them up a day, you're covering your building 100 square meters a day. So the time on site is greatly reduced, and also with that has increased quality for panels that are made off site. The other one, the big thing at the moment, is Derek, as you're looking at, you're saying there before, was the DFMA.
Yes, there's an increasing drive within the industry to design for manufacturing and assembly, and precast facades lend themselves very well to that. And we are increasingly being used in conjunction with precast frames and steel frames to increase the amount of construction carried out remotely from the site. Another big advantage of that is that the number of people required on site, which is becoming more prevalent in these times, is that the number of people is reduced significantly, as our installation crews typically only number 4 to 5 people. So there's a lot less people on site achieving a lot more, which is significant benefits both in terms of health and safety, site facilities, prelims, and as Darren has pointed out, the program.
Yeah, and then sustainability is a big thing now. It's hot. The whole green agenda is very hot at the moment.
Yeah, so we're far better able to manage our waste streams in the factory and manufacturing. It's designed for efficiency, and you far less waste on site. Yeah. Essentially, we don't create any waste on site as part of the main panel installation.
Well, that's interesting. So you mentioned about the speed and obviously being able to save program on site. Does that take away from sort of the architectural finishes or variations available to the architect, or is quite a wide range available there?
I would say not. You're probably giving them an awful lot more. You know, when we have architects out here and have a look at what we can do, and our sample room is like a kid in a sweet shop a lot of the times. You can just see what has been done, not just from TechCrete, but from other precasters, the range of buildings that have been carried out in architectural precast. You can probably do more with off-site manufacturing and precast than you would on-site.
The potential to use the precast panel as a base for then other finishes such as stone, brick, even terracotta tiles or glazed tiles. So you've those traditional finishes which can be installed as part of a precast panel or facade system, which is then also the benefits of different concrete finishes and textures and colours that can be created within the panel.
Yeah, the geometry of the panels can be a lot greater, a lot more complex.
In addition, a lot of this complex geometry can be included without the need for a significant amount of additional secondary framing and fixing required. Essentially comes pre-formed as part of the panel, which again offers a lot of cost savings. And again, you're reducing the number of trades, because very often on facades like this, you would have maybe bricklayers, you'd have SFS systems, you'd have window fitters, you'd have guys doing the aluminium or any brise-soleils, things like that. Even then, to connect yourselves, balconies. So being able to incorporate that into a single system offers huge benefits.
So you touched on it there as well. I guess what sort of common challenges may arise or complexities with some of these visions, or what could be designed out by, I guess, early engagement with yourselves and with us?
Yeah. I think that single statement that the early engagement is key, because a lot of, particularly with both the structural engineer and the architect, what we try to do is, for example, joint widths are probably one of the topics that everybody discusses. And I'm always at pains to point out that we don't actually determine the joint widths. The movement of the frame that we're attached to does. So by early engagement, we can discuss with the structural engineer and the architect what's the optimum panel size and placement of restraints and fixings back to the structure to reduce the relative movements and therefore joint widths. And then also parallel that, we can look at how we can panelize it to create the architectural intent, but disguise the fact, if you like, that it's a prefabricated facade, just by careful placement of joints, hiding them in shadows, things like that. So there's a lot of things that can be done if we're involved early enough in the design process.
Yeah, as Derek said, there is trying to rationalise the panel layouts, and we're also looking at the cost benefits of getting a lot of repeat panels.
Okay, so you mentioned there as well then, with the rationale and the sort of standardising it and obviously helping reduce the cost. I guess, is that one of the main benefits with having an off-site manufacturer as well, is it gives that ability to actually reduce the cost ultimately and increase the standardisation of it, the repetition, enabling the architect to actually still improve the programme, get it delivered to site quickly, and actually improve the construction and the quality overall?
Yes and no, but sometimes the precast panels can come across being more expensive, but you have to look at the overall picture of using precast. So you don't need any scaffolding on site. You don't need any excess. You try and fix a lot of the panels from the inside. You're covering the building an awful lot quicker, so your on-site prelims is going to be reduced. You've got your life cycle costs of the panels, and over the long term, it works out an awful lot more economical, because you can design the panels to the life of the building, and also it will always look good as long as you maintain it well.
And then even during the construction phase, there's other benefits like the number of site deliveries, that you're not having different trades, for example, bricklayers, mortar bins, different trades like that, getting a lot of deliveries to site. Other issues like maybe perhaps where you fitted your windows off site, which we do a lot of, which means your quality control, your QA auditing, a lot of that's done in our factory, our facilities, and your testing can be done again off-site remotely. So by the time your unit arrives to site, it's essentially it's an install, bolt-in, seal, and finished. Which I think that's where the true saving is.
Is there, I guess, with the off-site manufacturers, where you touched on it further on in the beginning there about the advantages, the sustainability, etc. Does the off-site manufacturer precast, particularly in this scenario, increase, because it's that environment-controlled factory, does that increase the quality and sustainability of the product that could ultimately improve the residential construction?
I think the quality of the product is second to none. It's manufactured in a controlled factory environment, even to the point that a lot of our brickwork pointing is done indoors internally. It's inspected through our own QA procedures, so the quality you're getting of each individual panel is inspected here, can be inspected by the architects and testing teams, which visit quite early. Again, also in terms of window installation, all of that. In terms of the sustainability, the transport costs aren't a significant portion of the carbon. We've taken a lot of steps and a lot of methods to reduce our carbon content and our carbon footprint of the panels, which makes them very efficient when compared with other forms, particularly when you consider that a precast facade will easily achieve a 60-year design life, and very small tweaks can comfortably achieve a 100-year design life, which is typically in excess of your structural frame. So precast concrete cladding is one of the only systems that your facade will have the same lifespan as your structural frame, which is provided, as Darren pointed out, it's maintained correctly. But again, by maximising the panel size and reducing the number of joints, you can assist in prolonging the life of your facade.
You mentioned there as well about the carbon footprint as well. Do you feel the move, I know there's a number of clients and big developers in the UK, for example, that are pushing more and more toward the carbon neutral. You feel that the off-site manufacturers obviously assist that?
Yeah, I think definitely.
It's becoming more and more popular, and a lot of the larger architects or practices are aiming for carbon neutral buildings. and they're coming to us and asking us what we can do and how can it be achieved.
I think that comes down to the early engagement as well. There's things we can do in terms of mix selection, panel design, rationalization, but also again that because we generate a very zero waste, in terms of because we control exactly how much concrete's in the panel, we tend not to manufacture more than we need. Here, most of our facilities are essentially carbon neutral. That's our goal, is to get to carbon neutral of everything outside the actual materials. And even in that, then we're concentrated on reducing those as well. So we can demonstrate a very low carbon. I suppose you can find with that it's a small effect, but concrete actually absorbs carbon dioxide as well. So it takes a small bit back in from the environment, which offsets some of that in terms of its whole life cost. We're also looking at cement replacement materials and other ways of reducing the cement content, which is the main carbon driver. But again, because we're manufacturing and lifting the panels in controlled conditions, we can reduce our cement contents as low as possible.
Yes, a lot of our processes are a lot cleaner than the standard British precast requirements.
Yeah. And we're actively looking at ways to manufacture in a way that requires less carbon, which is important.
Yeah, very. So you touched on it as well a bit earlier, obviously, about the involvement with balconies as well. I guess, could you talk us a bit through, we've obviously had a bit of in common between Sapphire and yourselves on the balcony connections, but could you just talk us a little bit through how what options there are for fixing to the precast panels and how that works?
Yeah, a lot of it comes down to the geometry of the panel or the architectural design of the building. To make a Sapphire type balcony work within our system. There's many balconies there that just goes straight back to the structure, but going with like a Sapphire balcony, which goes straight onto the panel, helps reduce the cold bridging through the structure, and the weatherproofing details around that makes it a lot easier. The structure of the panel comes into effect then. You may have to make a few tweaks to the panels to make that work. Gary will explain better on that.
Yeah, I think the key part of it is the geometry to start. There are some balconies that may not be suitable for installation on the panels, as Darren has pointed out. Where we can, if we involve with yourselves early enough, and we have been in several schemes, is that we can either look at essentially a moment connection where we cantilever the balcony off the panel with pre-installed fixings, and you install your studs, and then your cassette system slots over, or the alternative, which is essentially the 4-point hook system. From our advantage, there are some advantages and disadvantages to the system, but I think the advantages far outweigh the disadvantage in terms of there's a lot of reduced thermal and structural connections back to the main building, which is also minimizing your point of water ingress and thermal breaks in the building. Panel design, provided we optimize the panel to suit the balcony, and we have worked very successfully in the past at optimizing where the balcony is connected, particularly like, for example, a balcony that ideally would sit either side of a set of French doors or bay window exit, and we can get if we can get a concrete frame around that to attach the balcony to, it makes it a very efficient way of framing a window opening and accommodating a balcony. So it's a case-by-case basis, but we have been able to achieve some dramatic facades with balconies attached.
It comes down a lot to the architect's design.
And again, that point becomes early engagement again. Maybe, for example, trying to optimize the balconies that, for example, don't span across 2 or 3 different panels, that don't, looking at the depth of projection and ways of working with yourself so we can minimize the moments transferred back to the panels. So all of these are possible and offer great potential, because again, it's another issue of it's reducing time off on site, it's making the installation safer, and so that all of these things contribute to an efficient and safe environment on site.
No, that's really interesting. So that sort of concludes the questions we have here, but it's really interesting talking to you. We covered a few things around the zero waste, the speed, the savings to program, etc., that can all help increase this quality of construction.
Thank you. And remember, everyone, that we will be having the live Q&A at 1 p.m. today. So if you do have any questions for any of the talkers, please do enter them into the Slido app. I'd now like to introduce Nick Horton. Nick Horton's talking about balcony design, and he is from Sapphire Balconies.
Good, well, welcome everyone. I'm Nick Horton. I've been working at Sapphire for 14 years now. Today we're going to look at balcony design. We're going to look at some of the common issues that have been and look at some of the things happening at the moment in the industry. We're going to take you on a bit of a journey through that process. We're going to look at lots of different areas, but if there's a particular area you want to ask some more questions about, feel free to. We can go into that in a bit more depth. So today, firstly, we're going to explain a bit about the past and balconies. We're going to look at what the challenges have been in bouncing balconies, install challenges, fires, and so on. We're going to look at what is happening right now in terms of the new regulations around the fire side of things. We're going to look at the new British standard, which you may or may not know about. And lastly, we're going to give a bit of an approach for the future. What I would also say is we also run a event series called Resi Build. There's a separate website, resi.build, where there's a whole host of other topics you can learn about from lots of different speakers, not just about balconies. We'd recommend you go on there, have a look at other forms of learning if you're wanting to know a bit more about some of the other series which are happening at the moment. The next one is a debate on laminate glass, a live debate with several different speakers, and that's in a few weeks' time. So if you want to book on, go to www.resi.build. But in terms of balconies and the Sapphire experience, we originally established in 1992. 2006, we moved out of London, which is where we originally were. And during that process, we were very much based around making the kind of pretty bit of the balcony, the balustrade, not only. We're doing staircases, we're doing lots of retail stores all around the country. And with that, we, in 2009, started naturally getting pulled into the balcony market. And the reason for that was quite a distinct change, is that people started to move away from concrete balconies, realising the hassle and the difficulties with coordinating lots of different trades and bringing it into one package. And so back in those days, if you were doing a metal balcony, predominantly it would have been one company doing the steel work, one company doing the balustrade, one doing the drainage stuff, one doing the decking and so on. Much of the way a concrete balcony is done now. But in 2012, that changed quite distinctly. We'll show you a bit more about that as we go through. So to give you confidence, we're approved details with Premier Guarantee and HBC. We also sit on the British Standard Committee, who have written the brand new standard 8579, which is due to come out in August this year. It came out for consultation at the beginning of this year. We also do a lot of work with people like Exova or Warrington Fire, as you may know them, who specialise in fire and buildings. So one thing to be aware of is all our balconies come with a 3-part guarantee. The first part is that they'll be rigid, so we'll touch on this in a bit more detail a bit later on and show you the importance of that and also how you can optimise your anchors for that. We believe that a balcony should be ready ahead of time, and that when it does come to site, it's like a car. You wouldn't expect a car to come without some of the components assembled on it. And we believe a balcony should be made in the same way. So we manufacture in advance, we store them in secure locations, and we guarantee that when they get to site, they'll be right first time. If they don't fulfil those 3 criteria, we don't just solve the problem, we also give £100 back per area per balcony to make sure that it's a catalyst of self-improvement internally. So the point being really is that we strive and focus on these parts here throughout the company so we don't actually get it wrong and don't have to pay. So some of the schemes which we've worked on in the past, this one here was one which shows a few of the reasons why developers engage us. This was one in for O'Shea, a Galliard's home development in North London. And this was basically, there's 2 parts to this one which they were particularly concerned about. One was that the planners were very insistent on this timber look which had been submitted. So we created a wood effect veneer, a bit like a table veneer, but this one was actually out of powder coating, so it had an aluminium core and it wasn't going to rot over time, which is what the developer concerns were. The second thing was the curved area there had a lot of rebar. and they wanted to minimise the conflicts between the balustrade fixings where they're drilling into rebar. So we created jigsaw puzzle templates so they could join into each other all the way around. It could be optimised in the design office, laid out on site to grid lines, and minimise the amount of conflicts. And so they took us onto the next scheme to apply those same benefits there. The scheme is called Baltimore Wharf. This is the tower here. We've done a 20-storey block behind that as well. But the tower is the shape of the human eye. It's like an oval shape, and at the extent you've got these glass floors to them, 3.6 metres in length. You've got these big balconies around there. You've got over 10,000 glass panels on the balustrade alone. And each floor is rotated 2.5 degrees to give quite an iconic twist to the building. So each way you look at the building, it's different shape, which looks quite neat. But likewise, it's quite a difficult logistic challenge for actually building it because you can't use mast climbers and those sort of things because it's a curved building, it's twisted. So one of the key things they needed us to work with was to actually cast in advance. And so out of these fixings, and there's over 380,000 fixings on that scheme, not a single one of those was actually drilled on site. They were all cast in ahead of time. And as you can imagine, that was very much front-loaded in that design process. And then it was much more efficient in the build. And coupled with that, we also then created this shroud around the building, this white area you can see these pictures and what these people are working behind. The point of that was that could shroud the whole building, it could climb up floor by floor as you go up the building. And it was protecting people, so it didn't have to work with harnesses, it didn't need scaffolding. And likewise, it also meant that the wind wasn't so much an issue with installing those balcony balustrade panels. You can imagine if you're pushing a big panel out 46 stories up in an exposed location like that, there's a lot of wind. Obviously, that was reducing that. So they were installing one floor every 2 weeks, all the way through the scheme. So it's a 2-year scheme. But more traditional balcony types we work on are kind of the projecting cantilever balconies like these. We do a lot with the likes of St George. This is a scheme we've done. These 2 blocks here, we've done the block where that red crane is, and we're just currently working ones where the white crane is there as well. So this particular scheme here, this is one on the Greenwich Peninsula for Night Dragon. And the reason this is quite an interesting scheme is because their intent was to create quite a different variety of buildings, and they were in very close proximity one to another. But they wanted to make sure that they had the ability to change the aesthetic style of that from one balcony to other without actually having to redesign the anchors, redesign the drainage methods and all those sort of things. So what you'll see in these next slides is a load of balconies which look quite different, but actually are very similar behind the aesthetics. So you can see here some vertical bar ones with some white solid walls, one elevation, glass on the other elevation. We've got this one here, which has got like a facade I-beam type effect on the balconies. And they're also in a bronzy kind of gold colour anodized. Then you've got a variety of other different balconies all the way down those elevations. We are going to concentrate on rectangular balconies. They don't feel limited. Schemes like this one here in Reading has balconies wrapping around the outside of the building. It also has some very intricate dogleg shaped balconies inset into the building. And actually, inset balconies can often benefit the most because it's much more cost effective. You've got a lot more thermal savings and so on from using bulk metal balconies. So we're not really going to touch on Juliet balconies today. Terrace balconies, inset balconies, and projecting balconies. We approach all those three as a cantilever structure supported back from the main entrance where normally the doors be on a balcony. So a terrace would just be a series. It can be applied like that onto an existing building. It doesn't have to be a new build, although predominantly what we do work on is new build. So do any of you happen to have actually seen a balcony being installed before? Not too sure if anyone was trying to speak then.
Yeah, no, is a simple answer.
Okay, fine. We'll talk you through the process then of balconies. Traditionally, this is a job we did back in Battersea in 2009. So this is connecting to shock anchors in this particular scheme. And you're bolting onto them from the bottom, working from the bottom upwards. And the reason being is that you need to access those bolts. And then you stand on the next balcony up to access the one above that. So this is a picture of the install. So swinging balconies in. Average balcony and a steel balcony would be around 2.5 ton once it's got the soffits on there as well. But that's being pulled into the building, guided by the people below, and bolted on for working out the building. Because it's quite difficult and there's not much tolerance with those lining up two holes and getting a bolt through, it does become quite slow. And as a result, we're installing around 4 to 6 a day on average. And this is pretty standard for a bolt on balcony. Still much quicker than you can complete a concrete balcony because the drilling alone of concrete balconies to the balustrade fixing is quite a time-consuming process. Sorry, it seems to have frozen in a second. So we moved away from the concept of bolt-on balconies and moved to glide-on balconies, and the reason for this was twofold. First thing is that we're finding that quite a lot of the of bolt-on balconies we're connecting back into the building on end up feeling fairly flexible, even though they're completely within the British Standard and Eurocode guidance. They still felt flexible, and this was obviously leading to end users feeling unsafe as well. So that's a deflection at the end of that anchor we're talking about, the end of the arm there. So the first thing we did was we created a two-part system. So the first part here is where you've got cast in and the arms coming out of the building. And the point of that is that you can slide on a separate section, which gets clamped afterwards. And the two main benefits here, the first one from a strength point of view is that you've not got a back member to that balcony which is flexing and causing the whole balcony to flex at the end. That is taken right back to the slab edge, which is the best place to resist forces. And the second thing was that you didn't need to have that access underneath to line up holes. It gives us much greater tolerance, and likewise it enables the balconies to be installed without people underneath. It's much better from a health and safety point of view. Very first scheme we installed 22 in 6 hours. So you can see the vast speed difference there. And we've installed 36 is our record, but installed over 20 many times. And this is basically because you're taking a non-linear process which is quite time-consuming on site and doing them simply in a factory. So soffits, for instance, on a site, previously they used to have a bad reputation of being quite costly because you've got two people, one holding it, one fixing it through as you're working up the building. In the factory, you can turn the balcony upside down, and it takes about 10 minutes just sliding a balcony and riveting it on for one person. So it goes through a process which is about 3 hours for two people to 10 minutes for one person. It's a lot more cost effective as well, obviously. So I'm going to show this video which will hopefully give you a bit of an insight as to the whole process. This is a scheme in Southall. To get on to some of the more specific points of this, firstly, it does enable either a top-down or bottom-up approach to installing balconies. So it enables you don't have to work from the bottom up as like you do on a bolt-on balcony. On taller schemes like this one here, it can be an advantage because they don't have to strike all the scaffolding in one go. You can install it from the top down if they need to. On this particular scheme, there was some issues with some of the doors. They couldn't release a whole elevation they planned to, so they're only able to release a few. So it meant we could come in and infill just a few of them. But obviously, if you're installing top down, you need this counterbalance attachment, which is something which we've got a whole fleet of these to offset that crane hook and take it beyond the line as a balustrade. MMC becoming very much more common, especially up north, Manchester and so on, and in Ireland. One of the things which is, well, there's 2 points really on MMC schemes which are quite key. The first one is that a lot of MMC schemes aren't able to give the same strength as an RC frame would. So connecting to an outside concrete precast wall panel or connecting to light gauge steel, CLT, all these sort of solutions, we have connected to all of those, but all of them in common don't have the same strength. And therefore, using a lightweight aluminium balcony actually takes our weight from around 2.5 tons to about 700 kg, so 0.7 of a ton. So there's quite a lot of weight reduction, and that makes a big difference to the balconies and those sort of schemes. The other thing with MMC schemes is we tend to find, in the main, they don't have a dedicated site crane, or if they do, it's quite tied up with bathroom pods and other craning in other panels and so on for the facade. And with that, the install speeds are quite key. And this one here is one where we installed the first 24 balconies in one day and the next 34 the next day. And that was moving the crane around site on those days as well. So it's quite key that on a scheme like that you minimise the amount of crane time needed. Maybe for the benefit of other trades, but on this particular scheme, every day that crane was on site was a cost. So every day we were saving off the programme was a direct cost saving of several £1,000s. And this is one of the ways which QSs and so on can make quite a big difference to their balcony package, is actually by planning it right, so they can use the crane for the minimal amount of time and save the most amount of money. And last but certainly not least, people are all within the building, so they don't have to be underneath to line those bolts up. Much safer than having a moving load above somebody's head. Sometimes you need something slightly different, and this is what was needed in this particular scheme here. This is one in Woodbury Down, a balcony scheme, where we used a roof crane. Now, the point of the roof crane was basically that they could install this whole stack of balconies way after the crane had been struck, the tower crane. So they were saving the money on the tower crane, but the reason they couldn't install those before the crane went was because that's where the goods hoist location was. So they wanted to take all the bulky equipment up to the apartments in there. So we waited for the hoist to come down. We could take this cantilever roof hoist up in small pieces inside the internal goods lift, assemble it on the roof, and then install those 30 balconies. So we can go now on to some of the technical detailing of a balcony, the first part being the anchors. So the anchors, we're going to concentrate on the RC frame stages purely because it's most common. The second part, the thermal brake. And the third part is a 1 or 2 piece arm. I'm not really going to spend much time on this today. 85% of balconies we do are in this kind of location where you've got two pieces, this sort of scenario. And the point of that is that if you have a 1 piece arm coming out, it can be cheaper, but it can also be a bit of a pain for scaffold lifts and all that sort of thing. So it generally ends up being a 2-part install. So they fit the second part as you're coming down the building, and the scaffolding's being struck. So the key thing to get right here is rigidity. If you don't get the rigidity right, it's A, very costly to put right, but B, it forever causes a problem with resident complaints and so on. Often the rigidity and the thermal performance will actually fight against each other, because obviously the more metal you've got in something, the stronger it is, but also the worse the performance is. We'll show you how to balance that. And thirdly, it's really the simplicity to cast in, because that's where a lot of the tolerance challenges used to come from the days when we did bolt-on balconies. So, does anyone know how much this balcony here would actually be allowed to deflect? Does anyone know what the Eurocodes require? No? Well, sorry, go on.
No, I don't. No.
So the length of a balcony and any cantilever structure is allowed to deflect to the extent here of the length divided by 180. That's the formula to use. So putting that in simple balcony terms, often the cavity is about 300 mil from the slab edge to the outside of the facade line, going from there to the inside of the balustrade. Normally it's 1.5 metre turning circle for a disabled user. So adding those together, you get 1.8 metres. Divide that by 180, you get 10 mil of movement at the extent of that balcony. And our belief is that on 1.5 metre balcony feels small. To get 10 mil of movement on that is quite a major amount of movement. And this is why those complaints are there, because it may be only moving 4 mil. It might be far inside those Eurocodes, but at the same time it feels flexible and it doesn't feel safe. So what we've been looking at is how can you minimise that? It's basically by addressing the way the moment force is dealt with. So the stretch at the top bolts, and at the bottom bolts, we don't need to worry about stretch, you've got the compression. So the first step of that is to actually get a much more rigid anchor. And this has got other benefits as well, one of which is the fact that by having a stronger anchor, you need less anchors. Massive cost saving. Also, we'll touch on it from a thermal point of view in a second as well. So the first thing we've done to the anchor system here is we've increased those top bolts from an average M18, M20 or M22, which are the common size in the marketplace. We've increased those to an M30 diameter, so quite a chunky anchor at the top. That really does reduce the stretch. That's a stainless steel bar, stainless steel because of corrosion, but also because of the fact it's much better thermally than galvanized mild steel is. Second thing we've done is spaced out the horizontal and vertical spacings of the I-beam, of the bolts there to enable an I-beam to be put in the optimal position. Now this can make it much simpler to achieve a level threshold and so on, but ultimately the strongest place is between those two sets of bolts where it can resist to the maximum. The third thing we've done is split out the thermal brakes. So the bottom bit there has got a compression plate. So that's normally like a Farrex type material we use. And at the top there, that we used to use polystyrene, that most people did, and we've changed that to a mineral wool. That is obviously voluntary because that is actually exempt in the fire regulations, but we do still think it's a much safer approach. So we had a number of issues back in the bolt-on balcony days, and this was one of the schemes which we've got a few photos of. Now, some quite horrendous issues here, some anchors casting upside down. Not really a reflection at all, any of this on the anchor design, but this was actually the casting basically. And so we looked at this and said, how can we quite regularly get a site engineer sign off an anchor as being within a 2 mil tolerance, and actually after it's cast, it's far outside of that. So we did a bit of a study on casting. What we realised is that actually a number of these anchors, people were stepping back as they're casting it and treading on it. So that might just dip in front of it. It might rotate that anchor and so on. And that's one of the first things we discovered, is that that's probably part of the issue in there. So what we've done here is not only introduce 20 mil of tolerance because you're starting an aperture over an arm rather than lining up 2 holes, but we use spacing templates to lock them or rigid, stop that rotation. But also, if somebody does tread on it, it's actually spaced off the casting table as well, which means that people can tread on it without actually damaging anything. So some of these things are quite simple to do, but they're quite imperative to actually make sure you're maximising the tolerance. As I touched on earlier, thermal, quite a complex area, but we've done loads of studies on this. We've actually got a specialist fridge for testing thermal connections on balcony slabs in our R&D lab in Reading. But one of the key areas to look at is less heat loss comes from less anchors. Less anchors, less heat loss, simple formula. but that also makes the whole water penetration and the fire stopping around anchor design and so on a lot simpler as well. So it saves a massive amount of cost. It makes a lot of sense from a rigidity point of view, having stronger anchors and less of them. But thermal, that's one of the big areas of benefit. So I'm not really going to go into the fire stopping in too much detail on this slide, but we've tested many different scenarios. If you do want information for a project, there is some available on our website, or you can download the fire white paper, which gives you an in-depth review of all the testing we've done, all the things we've found. But ultimately, there's two things you need to comply with. One is the 2-hour fire protection in terms of insulation, and one's the actual integrity of that. And that you're needing to worry about behind the facade line. Outside of the facade line, it's all about being Class A. So we see on this slide here is what we call a stub guard. It's a simple solution for actually allowing in that spandrel zone where there's quite compact and a lot going on there. You can bring your fire stop, your fire cavity barriers up into the fire stop guard around the anchor. What that means is that you can place that on, you can slide it back into position because it's a CNC routed item supplied from the factory. Is that you can't actually get upside down, and it's quite simple to interface with either a cavity barrier or a linear joint seal, like the right hand side of that one. Let's say we do other connections to a CLT example, and there's many other solutions we've connected to, including existing buildings. Now going on to the cassette structure, that's the bit you're working on. The first thing to get right is designing it proactively to resist fire. The second thing is drainage, and we'll come on to some guidance from the new British Standard about that in a second as well. So the decking runs parallel to the building. We're not really going to touch on decking today. If you want to know about decking, we recommend you get in touch with our preferred choice of decking, which is MyDeck, MYDEK. But from a fire point of view, you've probably all seen this document, and the point of showing this part here is one of the issues at Grenfell was the fact that above the 18-metre mark, the height of the building at Grenfell was that should have actually been to a Class B, where it burnt like a C. Now, at this point, balustrades and balconies were not actually included within the standard for fire, and there's a number of other exemptions as well. But even after Grenfell, there's been a number of different balcony fires, and we've done extensive balcony fire research. If you're wanting an in-depth research, if you go onto the Resi Build, IESI.build website, there's a number of CPDs which we do on a monthly basis. First Tuesday of every month we do a CPD, and there are 2 on fire which we do, one about how to make a balcony fire resistant and one about these kind of incidents and so on from the research we've done. So feel free to sign up to any of those. But this one here was a chip pan fire, started on the 9th floor, spread out to the building and rapidly went down to the 8th floor and all the way up to the 14th floor. Now, the 2 recommendations which came out of this, one was that the Manchester Fire Brigade recommended using metal soffits to deflect heat, but also contain those embers, and they also recommended designing out all the timber. That's obviously now mandatory, and that's the height building. But this is part of what we found out during that research. When the Dame Hackett recommendations went out for consultation midway through 2018, and within a 2-week period, there happened to be 6 balcony fires in the UK, some which were quite significant. This one top left-hand side was one in West Hampstead, and started on a podium level and spread all the way out the building. And that was a brand new building. Again, we've dealt with the London Fire Brigade. None of those schemes are ours. But we do a lot of work in London and Manchester and all the areas around. So finding out how things are happening, what the causes of them are and so on is quite a key area for improving balcony design for the industry. One of the differences between this balcony and the one at West Hampstead, which burnt significantly. This one here is actually one of ours, and this is where our balcony journey started into balcony fires. And this was actually before Grenfell. So by the time Grenfell came, we were already researching fire in quite a lot of depth. But what happened here is somebody was smoking on the balcony above. They flicked their cigarette off, and it landed on the one below. That landed on a beanbag and caused quite extensive damage to that balcony. You can see the smoke damage to the one above. You can see the marks contained at the bottom there. But ultimately, the glass was smashed by the fire brigade, so they could actually spray the hose on. You can see that they've also straight cut those boards to stop it spreading further along. So really, this showed to us the importance of the role of soffits. This balcony here has a Class C decking. Class C is obviously now banned, and it had a Class A soffit. The only difference between this one and the ones which burnt considerably back in that previous slide at West Hampstead was that the ones at West Hampstead, they didn't have a Class A soffit, they had a Class C soffit. And that really showed us the importance of how fire spread can be limited by using soffits. Same with the Manchester one, really. Sorry, was somebody just about to say something? So looking at the timeline of the ban and what's been happening, the ban was obviously announced end of 2018. It lacked clarity originally, still does in a number of areas. Balconies have obviously gone into that, and the only exemption to that is gaskets and so on, and thermal brakes, which are needed for Part L. It applied from the 21st of December. And you may or may not be aware, but there's a few more changes in the pipeline now. There's a consultation currently out around laminate glass. Quite a topical question. We'll talk about that a bit in a second as well. But just for your interest, this is a video we did before the ban came in, actually. This shows the difference between the Class A, Class B, Class C, and Class D balcony. And it shows really the behaviours of how these different deck boards burn on a small sample of balcony. So you can see that basically it does make quite a big difference between the different boards. The Class B even was quite a lot better than the Class C. But our recommendation is that even if it's under the mandatory height, 18 metres at the moment, potentially 11 fairly soon, if the condensation is approved and like what Scotland have already done. But even under that mark, we'd recommend you consider at least using soffits and also definitely going for at least a Class B if you're going to go for a combustible soffit. Our recommendation is always to stick with the aluminium. So moving on from fire onto drainage, there's generally been seen as two ways of draining balcony. We've got free draining, we've got pipe drainage, or positive drainage as it's commonly known. Now, some of you may have had had experiences previously within HBC around this. Their guidance has generally been the go-to for the industry because there hasn't been any British standards or any other guidance which has pointed people to how to drain a balcony. And even the NHBC guidance is really about concrete balconies. One of the things which they suggest is draining a 6 square metres should be drained as per their 7.2 pitch roof document, which basically says it needs to be water managed. So on the roof, that makes a lot of sense. So you're draining it to a gutter and then take it down a rainwater pipe. And that's the kind of concept here. You bring it back towards the building and down a pipe. Free draining is being considered to be anything outside of those parameters. So if you've been draining all the way through, or you've got perforated soffits, or perhaps you've even been taking it to the front like this particular drawing. The good news with the British Standard 8579 is that basically they're actually defining those two categories into 3 categories. And the point being is that there needs to be a distinction between balcony where you are draining and when you're doing nothing at all too. So the easiest way to remember these 3 categories now is that basically the first one is if you had a cup of coffee, you poured it on your balcony, it's what would happen to the one below. So below the balcony, if it was free drained, we'd end up with the coffee on it. On a controlled draining balcony, that would have been taken to the side and dispersed, or to the front and dispersed. You're doing something with that. It's not going to end up in the balcony below, except perhaps a couple of drips which blow back in or something. Pipe drainage, however, would take that to a rainwater pipe and down to the ground. Now, the interesting thing is that the recommendation of the British standards is actually this middle category, not pipe drainage. They recommend that you should be draining a balcony to the front edge, and the reason for that is to drain it to the front edge makes more sense because you're taking it away from the building rather than taking it back towards the building, which is obviously a bad principle from a water management point of view. But they also recommend that you do it in compartments because then you don't have any build-up and concentration of water. Obviously, a pipe drainage system would need a concentration of water. You need to get it all to that one pipe and then down. And that 6 square metre rule was debated at quite some length, and basically there is no basis for having that apply to stacks of balconies. Quite a different story when you've got it draining a roof, a pitch roof, and that makes complete sense for draining it to rainwater pipe if it's over 6 square metres. But you see these balconies here, and this photo demonstrates this point quite well, is that where that balcony was 10 metres square or 2 metres square, doesn't really make a difference. What makes a difference to all those balconies in that stack is where they are. So you can see there, the top one's got a bit of water in it, the one below, tiny bit of water in it. And as you go further and further down that balcony stack, it gets drier and drier. And that's really the point, is that it's pointless of all those balconies being positively drained to a rainwater pipe, because ultimately they're being protected from by the one above. At this point, I've demonstrated this. you can see there's been quite a debate in the industry about how to drain balconies. We can see in practice it doesn't really make much difference between them. So moving on to looking at the balustrade detailing now, the third element of the balcony. The first thing to get right is the balustrade height, then the regulations which apply to that form of guarding, particularly this glass, and then the base fixing. So I guess some of you here probably know what height this balustrade should be. Who knows? So the balcony under BS 618 and the parquet regulations should have a height on the balustrade of 1.1 metres. Now the point of this really is that it would stop people climbing over. And well done, Paul. We got it right on the chat, I just noticed. The point of this really is to stop it from being climbed over. It's ultimately a guarding, stopping from a safety point of view. Now, this particular scheme, the reason we use this picture here is it demonstrates quite an important part to get right. This scheme here, we installed a balustrade originally. It was 1100 high, and they came and did all the finishes and so on. Changed a bit of the design as it went, and ended up with the building control not signing it off because of the fact it was under 1100. Now, the reason for that could have been a load of different items. It might have been that they tried achieving more of a level threshold and so on. And it was only a few millimetres under 1100, but they would not sign it off. So on this case, they're quite lucky that they'd chosen offset hammer, so we just extended those brackets, so we raised the hammer height. The point being really is that we shouldn't need to do this. It should really, if we plan it in from the start, and we automatically do it on all our balconies, we add another 20 or 30 millimetres to the top bit. We just recommend doing that. The other thing to be aware of is further up the building, if you increase the height from like 1100 to say 1300, you can make a big difference to the usability of a balcony, because it means it's much more practical from a wind point of view as well, if it's solid like this. So a famous structural glass balcony is one where the glass is taken below, there's no posts. And there's 3 videos here which really demonstrate what you need to do with glass. Now these are videos from back when we were promoting the use of laminate glass as a safer alternative from monolithic glass. So what you see here, these videos are about 12 years old. So you're smashing the most vulnerable point, it then smashes into lots of small shards. Theoretically, this is the whole point of safety glass, but believe me, they wouldn't feel that safe if you were showered from the 30th floor with that. And then the alternative to that is using an equivalent strength, 10 plus 10 with laminate glass. So this is smashing those 2 panels. The first one there has been smashed. You can see the benefit of using laminate glass. Now, as you're probably aware, laminate glass is no longer allowed in the balustrade because it's inadvertently being banned in the requirements for Part B. The document which was released had an exemption for laminate as used in a window scenario that didn't mention balustrades, and therefore is inadvertently being banned. Now, there's quite a lot going on behind the scenes. There is a consultation out at the moment. We've been doing lots of testing with the government and with fire brigades and so on. We did a quite significant balcony test, burning a whole balcony and seeing how monolithic and laminate glass performed on the same scenario, burning it with your whiff chairs, bamboo screening, all the sorts of things people have on a balcony. And we're launching those results and having a debate with a number of glass experts in the industry in just a couple of weeks' time. So if you want to join on and see that debate, if you want to suggest questions, you can do all that on the ResiBuild website, resi.build. But in the meantime, looking at glass options, monolithic or laminate, it'll be fixed the same way. You can have a fascia trim at the bottom, it's screen printed or obscure as well. That often helps avoid things like combustible boundary screening being needed for privacy. So they're fixed the same way, both point fixed with a screen print or where you've got a fascia trim, they've just got mechanical fixings through the glass. So as you can imagine in that glass, laminate glass, you saw the second panel, it stays, it maintains its strength for a bit and then slowly starts losing its strength. If it's got a handrail at the top, it's got fixings at the bottom of that glass panel, and it's not going to go anywhere. And that's the real big safety benefit of laminate glass. So 8.5.2 of BS 6180 has two parts to it. And bear in mind, this British standard is now actually 21 years old. But the two parts to it, one is that you've got a second form of guarding. So if you were leaning on a balustrade and it collapsed, the glass smashed, for instance, you would actually have a second form of guarding. The handle would stop you falling off. And the second is that would withstand the load by itself. Now, there was a tragic death of a young toddler in Sheffield a few years back. And as part of that, this really led the industry to really start thinking more around using laminate glass as a solution. So you've got those two forms of guarding the whole way across, because ultimately that toddler was unfortunately not tall enough to be protected by that handrail. So with that, the British standards at the time in 2011 updated this to say that basically you didn't need a structural handrail if you're using laminate. But with that, that also meant that the cost of using laminate glass was then more cost effective than using monolithic. So moving on to framed systems, the most common of which is the vertical bar. We'd recommend using rectangular bars. They're much stronger and can achieve your loads with much simpler hollow aluminium extrusions. If you go for a round, you have to use a stainless steel to get the strength, and it needs to be quite strong. So it needs to be quite a thick bar, 25 mm diameter, and becomes very, very expensive. Base fixing doesn't really make any difference whether you've got fascia behind or in front. It is cheaper to have the fascia behind on the rectangular bars. There's a few safety features you can simply add to this as well. There's a few on this particular scheme they've used. This one here, at the top of that handrail, you've got a slight slope on the profile. So by having a slope, it means if somebody put a glass on there or a plant pot or all those kind of items on a balcony, if it fell, it would be more likely to fall onto the balcony than fall down to the floor. One we definitely advise is the kick plate along the bottom there, which is basically just extending the fascia up very slightly by 30 mm, 40 mm to stop something rolling off the edge. So same as the kick or the scaffolding. There are other alternatives, perforations or solid walls, getting more common now, while glass is banned in laminate. Monolithic glass being used with a frame system becoming more and more rare because it is cost effective for a concrete one, where you need a big base channel for a structural glass, but it's actually more expensive to get this look, and doesn't generally look as aesthetically pleasing either, the structural glass. And normally it's only used in scenarios like this, which are quite reflecting the heritage of that particular area, and so on. Any questions? We'll skip on and come back to that in a second. So one thing we'd recommend is you use the balcony configurator we've created. This is a 3D solution, which can be used on, can be found on our website. We've actually just launched the latest version of it, which is basically a 3D rendering, and you can play around with. You can get views from the inside, from the outside, you can see the angle positioning and so on, and then you get quite a detailed report completely with BIM drawings your MDS spec created. So you're choosing by aesthetics, and it's generating all the technical stuff behind it and giving you those outputs. So I'd recommend you have a bit of a play around with this and get the items you need from it. It's called CAPS, and it's found on our website. So hopefully we've given you a bit of an increased knowledge in the area of looking at what we can learn from the past. Hopefully we've given you a bit of info on what's changing at the moment in terms of fire regulations, in terms of the British standards and so on, and giving you a bit of an approach to the future. Thanks for your time, and if you have any questions, please ask them now.
I've got a couple for you. Paul here.
Hello.
What's the lifespan of balconies typically? Have they got a limited lifespan, or are they?
We designed for a 60-year lifespan. We over-engineered them, but that's what the components will last to. It does obviously depend where it is and what maintenance the balcony gets. For instance, if it's on the seafront and so on, and depending on whether it's a complicated one with lots of welds and so on, is more likely to be vulnerable. And with the majority of these systems in aluminium, it's designed for 60-year lifespan. The anchors back into the building are over-engineered, so they're designed for a lot longer than that as well. Because obviously that's the bit which just cannot fail.
Thanks. What about a testing regime? Are they something that needs to be inspected every sort of 5 or 10 years? The sort of security and fixing and things like that?
We do recommend it. We've done an extensive, with basically aged balconies quite considerably with the UCAS accredited test house and Lucidium, where we've done high-growth thermal chamber testing on different components and what happens to those over a period of time with salts thrown and all the rest of it. And we've also done vibration tests, so continual vibration over time and seeing what would happen. We do have some recommendations, and I can send you a link. It is on our website as well about a recommended testing regime. But ultimately, it's a visual inspection. Everything can be accessed from the balcony itself. It doesn't need to be. You don't need to get a sort of scissor lift or something and look at all the balconies from the outside. No, you can do that if you can't. But everything can be accessed. All the bolts can be seen. If you take up some deck boards, you can actually see all the bolts within the balcony as well.
Okay, there's no statutory requirement for inspection, though. It's just a sort of good housekeeping sort of thing to do, is it?
Yeah, correct.
Lovely. Thanks, Nick.
In terms of other testing, we're obviously doing mass amount of fire testing. So our sister company, MyDeck, who do the decking, they've got lots of fire testing done. And we've got an in-house test house in Reading, and we've got quite a major amount of different pieces of equipment there. So we do destructive testing on any new detail, and we normally take one balcony per project as a type and actually test that in various different aspects as well, from natural frequency testing to strength testing and so on. So we do quite an extensive amount of testing ourselves. That makes sense, even though it's not mandatory.
Yeah, thanks for that.
No problem. Any other questions? Okay, so if nobody else has got a question, thank you very much for your time. Very much appreciated it. And don't forget to check out the ResiBuild website for further areas of information or accessing other recordings and so on. Thanks very much, everyone.
Thank you, Nick. We'll now be joining everyone on the live Q&A panel. So please do remember that if you do have questions, enter them in. If you've joined us on Zoom, then put them in the chat function. Hello and welcome to our event today, and thanks for watching so far. I hope you enjoyed all the presentations and the interviews. I'd like to introduce our panel today that have joined us. We have Elston Gurr from Sapphire Balconies. He's our sales manager, and he gave us a presentation today on better costs through hypothesis. We have Laurie Pomeroy. He's from Duty Point, and he did our presentation today on off-site manufacturing pods. Andrew Parsons, our technical director at Sapphire Balconies. He did a presentation for us today on effective water management of balconies. Archie O'Donnell has joined us. Thank you. He's the environmental manager at i3PT, and he did a talk today on ensuring quality in Irish residential construction. We also have Richard McMullen, who's head of business development at MyDeck, and he did a talk for us today on the essentials of safe balcony decking. Derek Russell, who's the design and engineering manager at Techcrete, who did a quality facades for Irish residential construction. And then we have Nick Horton, again from Sapphire Balconies, who did a CPD today on balcony design. So thank you everyone for joining us today. We have some questions that have been sent in, so I will be going through those with you. And so, just going to bring up the first question. So our first question today was to Elston. So Elston, thank you for joining us. The question that's sent in was they felt that it was a very impressive number of balconies to install in a day that you spoke about today. And you talked about cost savings, but what's the average install per day though? So obviously the number you gave was quite a high number, so people I think want to just know what the average number is normally.
Yeah, certainly. No, I mean, it is a high number. Our average is 15 a day. So we can say that we've done that time and time again. We actually are hitting 20 quite a lot more regularly now. So our record in the past has been 34, and that was a bit of planning behind that. But we're confident to say that we can achieve 15 a day.
With 15 a day, obviously you spoke about savings. That's obviously going to be quite a lot of savings to people. Can you just tell us a little bit more about what impact those savings will have? I think you spoke about crane hire and things like that.
Yeah, certainly, exactly. So we like to engage with the contractors at an early stage to help planning the logistics on site. So normally the most common form of craneage is a tower crane, and we would like to work on a full day at a time. So if we can plan with you 15 a day, we can use the hook as much as possible on a single day to get that number of balconies in. That means that throughout the project, if we're regularly hitting 15 a day, we will cut down the number of weeks we need the crane for, and therefore the crane can be used by other trades, or the crane can be taken off site early. So it's something we like to spend time with you planning, and also with the balconies being very lightweight, we're often using mobile cranes, which is a much cheaper form of craneage, and that can bring further savings as well. So really about talking with us and planning your logistics on site is something that we like to do to try and bring those savings to the table.
Thank you very much there. So our next question, I think it's going to be is quite a relevant one at the moment. It's towards you, Laurie. With present restrictions in place on site, do you believe off-site production will be the way forward?
Well, yes, very much so. I think it's proving that already over the last couple of months. It is definitely more interest because of that. We've actually taken some measures ourselves on some units we're building, so that all the panels we actually use are a one-man lift rather than a two-man lift, so that we can actually get
pods in. Does this help reduce the manpower on site as well? Is it easier to fit them as opposed to doing it like?
current restriction, it reduces the number of people you'll need in a small space at a time to actually fit them.
Great, thank you. So our next question is what kind of different soffit options are there, and what are their benefits? So I believe this will be to you, Andrew, with the drainage.
Yes, certainly. So soffits on balconies offer a whole range of advantages, aesthetics being the obvious one to the man in the street, but we've done a lot of research on the effect of fire on balconies and found that having a soffit has a big contributor to preventing the spread of fire from one balcony to another, and also for dissipating any jetting flame from that might come out of the building. So in terms of different soffits, some architects specified perforated soffits, which somewhat defeat the object because they still allow liquids to fall through. They don't contribute to the drainage advantages, and they don't totally help the fire, mitigate the fire risk. So we advocate
was saying there, with fire, we've done various different tests in conjunction with Exova in terms of fire, different types of materials and so on. In that context, it's certainly from all the research I did with the fire brigades across the UK and in Ireland as well. It's one of the big recommendations that comes out of many of the incidents which happened, incidents which you've seen it in a positive light of a case in, there's a fire in, on the Greenwich Peninsula where that actually contained the fire to that balcony and stopped the smoke from damaging the one above. And likewise, and from a negative point of view, fires like West Hampstead, the one in Manchester Lighthouse, and so on, where the fire brigades identified that one of the key things which could have been introduced and which would have avoided fire spread would have been the soffits, particularly metal ones, which affect heat as well.
Add one other interesting point that we found for our one of our Exova tests, where we were comparing steel soffits and aluminium soffits, and one would have expected that the aluminium would give less protection. We actually found it gave more protection, because as the temperature rose, the steel actually glowed red hot and caught things on the balcony above the light before the aluminium, which being a duller material, actually reflected the heat downwards, so that the first cause of fire above the balcony was caused by the steel sheet rather than the aluminium one.
Thank you very much. Our next question would be to, bring this one up. Derek, I believe this one was. What would you say one of the biggest barriers that stops people using MMC?
I think there's several barriers. One is obviously it's knowledge and understanding of what's available and what can be achieved offsite and the benefits. There's also perhaps a misconception that you can't create unique geometries of facades. I think historically it's maybe had a bit of a reputation as being very generic and modular, but certainly we found we've been able to accommodate lots of, still retain the architectural intent and allow a large degree of architectural expression while still manufacturing offsite. And I think that understanding is changing more and more with some of the benefits that we've seen outlined today. Reduced numbers on site, speed of construction, getting your building watertight quickly, just to name a few.
That's great, thank you, Derek. Archie, I think this one was for you. You spoke about I3PT becoming involved early on to make the most of it, kind of thing. At what point in the project would I3PT normally become involved in a project? I think Archie might have frozen. Are you there, Archie?
Muted.
Yes. I'll mute you.
Sorry, my Zoom crashed there.
Yeah.
Sorry, could you repeat the question, please?
Yes, of course. At what point in a project would I3PT normally become involved? I know it says try to get involved as early as possible. So what's the ideal time for you to become involved?
Generally, it's before tender, but we find with some projects we're getting involved much earlier in the project. And your last question was about modern methods of construction. Where projects are using things like light gauge steel or precast concrete, or you know, they're predominantly built off site, we're getting involved earlier in the project to evaluate materials, product systems. So with a move towards NZEB, higher levels of performance and more distributed supply chains, we find that clients and developers want to identify any constraints with compliance and delivery as early as possible. So, you know, we'll be brought onto a project to evaluate, say, if a particular method of construction is going to be fit for purpose. So it could be a very novel way of building. You know, we've seen this a lot with external wall insulation systems, and we've seen it with off-site technologies, some timber-clad buildings, where we're brought in early to engage with the supply chain and to look at procurement at a very early stage while the building is still in design development. So that could be as early as planning stage. And what we're noticing is that buildings that are designed for offsite and are designed for efficient delivery, they have a different method of construction. Like they'll utilize parametric design in BIM. They'll be designed with offsite in mind. They'll be designed with, rapid build fast track in mind. One of the difficulties we saw with offsite construction was that it was being applied to a traditional designed building. So a building that's designed for cavities and masonry and concrete frame, that a decision is made late in the process that would be delivered as a modular or an offsite or a light gauge steel or a precast clad building. And the design can't really adapt to that. It doesn't have the repeatability. It doesn't have the modular grid. And so what we're finding is that clients that are looking for efficiencies at construction stage are trying to design and plan for buildings. They're putting more emphasis on design coordination and technical submittals almost at the planning stage, at a very early stage. So the whole design process has been eliminated to put a lot of decision making up front, and a lot of technical evaluations are happening up front. And we are finding that we're engaging and coordinating with the supply chain, with a very dispersed supply chain, quite early in the project, just to do that technical acceptance of those systems. And in particular, to look at the interfaces. Like, it's great to see the interaction here between different suppliers, like between the precast and the balcony suppliers, to actually look at where they interface. How can they make that cleaner and more efficient at site stage?
I think with all the things we've been talking about so far throughout the Resi Build series, Kelly, we've touched on BIM, we've touched on MMC, and we're looking at a variety of things here for the Irish market in particular. But a lot of this really depends on making things more effective by early engagement. I don't think any of the panel here would probably suggest anything else, but the fact is that it doesn't limit the options further down the chain. It actually enhances the savings and the collaboration and cutting out the unnecessary costs by actually engaging in an early stage. As Elston looked at earlier, looking at engagement, designing in the anchors and designing out the number, or reducing the number of penetrations through the building. And no doubt it's probably the same with the likes of Derek and Laurie on the call as well. Is that early stage, you can do a lot more with actually in collaboration to the other interfacing trades and actually cut out a lot of the cost, and which is unnecessary, rather than it being something which perhaps at the moment seen as a bit of a, if I engage a supply chain early, it might limit my options further down the chain. It'd be interesting, Laurie's thought or Derek's thought on this point as well.
I think from my point of view, I think echoing that there is no downside to early engagement. And I think echoing on from your point, Nick, that the biggest savings or the biggest benefits are generated early on in the design process. So the earlier those decisions are considered, the bigger the impact they can have in terms of efficiencies and savings. But as you pointed out, that doesn't necessarily or shouldn't be seen as restricting options later on. What it just means is you're maximizing the benefits that you can gain through early engagement, but you can still retain the flexibility as you progress further in the design process.
Back exactly what you say there, Nick, is the earlier you can get on design and actually get into MMC, the more effective it is. We have found it possible to go in late, but it just you come across obstacles all the time.
You've also missed a lot of the opportunity to generate the truly big savings or big efficiencies when you arrive late.
I think definitely echo what Nick and Laurie and Derek have been saying. I think one of the things that we've found is that in terms of MMC and modularizing, it doesn't mean you're restricted to a very much kind of, in terms of balconies, we're not just restricted to square boxes. We can actually work with different sizes. We can match the architect's intent to a certain point. We can work with different shapes. But what we're finding is a classic one is that we find we can get a mass array of sizes or a mass array of shapes that are very similar to each other on a project. And actually just with some small tweaks, for example, we had a project that had 40 different types of balconies, and just with some small tweaks to the sizes, we were able to rationalize them down to 20 types. And that can actually bring in some very, very large savings, even up to 6 figures on a large project. So it doesn't necessarily have to be a dramatic change on a scheme. It can just be a few small tweaks, and working with you to work with the likes of architects, structural engineers, contractors to make those small tweaks can actually generate a much bigger saving than what you may originally anticipate. So just talking to us, there can be some small things we can change for some big returns.
So I guess it comes back to the question of what's the point of going down the MMC route? And really, ultimately, it's about building quicker and building more effectively, which ultimately will reduce the costs in the process as well. We talk about a labour shortage in Ireland. We talk about in the UK. We talk about Brexit and the knock-on effects. We talk about the housing crisis. All these things reducing the amount of availability and speed becomes even more important. And of course, now with the as was alluded to earlier on the call, you then have the extra COVID side of things, which is reducing the amount of interaction on site and people working together. And it's taking things off site and automating them in a factory and so on is quite possible for, as you mentioned, Laurie, some of those processes. And it's becoming ever more important to the marketplace wherever we are in the world, especially for Ireland and the UK.
That's great. Thank you, guys. Talking about, obviously, we're here now today to talk about the Irish market and everything. With environmental factors becoming more and more important, and we found that in our research in what's important out in, let's say, Dublin. I know, Derek, you spoke about like your carbon footprint and working to like reduce that. Would you like to give a little bit more information on that, and then maybe we can open to the panel as to what other companies are doing to help?
Yeah, certainly. It's obviously been a big driver for ourselves in terms of precast concrete. I suppose the initial one is that obviously we're doing everything we can to reduce our carbon footprint. A lot of our processes now are approaching carbon neutral in terms of anything related to other than the material itself. On the material itself, it actually also ties into the early engagement. If we're rationalizing early on and optimizing our panel design, we can reduce the volume of material we need, which is one way that we can obviously reduce the carbon content of that product. Another important point to note, particularly about our own product, is that it's relatively net, but the lifespan of our system is essentially matches the structural frame. So in terms of a whole life carbon cost, it works out quite efficient. It depends when you obviously start your measurement and finish it. We do have a specialist on board in-house now that we're actually actively monitoring our carbon levels and our consumption and actively planning to reduce that. So there's lots. It's obviously become a lot more. There's a lot more focus on it in recent months, which is a good thing. And I think it's just something that will become part of your delivery. I can see in the future that we will be assessed as much on our carbon content as our economic costs or potential of our product. That applies both to the UK and the Irish market as well. It is just going to be the way it works in the future. So I think every company needs to embrace that and consider the overall scheme, look for best value in terms of financial benefits and carbon benefits for the whole scheme, not one package in isolation. I think that's very important.
I think you touched on an important point there, Derek, about the whole life cycle costs, because many firms will perhaps focus on one area where they're making some quick wins. But I think that ensuring you use materials that are recyclable and also easy to transport, efficient to transport, all these little things enter into the total carbon cost and mitigating that.
And that can be as simple as, for ourselves, for example, it can be as simple as trying to drive a small bit of panel thickness out. That means we get potentially 4 panels on a trailer or 5 instead of 3 or 4. And that represents a big saving in terms of transport costs or carbon costs associated with transport. So again, it's small efficiencies add up in this, I think, as you pointed out.
So it could be with MMC, there's obviously one of the key things of making it carbon efficient, if you like, during the build stage, is actually designing it so that you can get as many on a lorry at a time, and that's what actually also reduces the cost, as you say. But from speaking with the expert recently, which we interviewed in this area, one of the things which was quite clear on the approach of it is actually looking at what the long-term overall is, rather than looking first for an offset. And the offset should come further down the line if other things can't be achieved. And one of the things which Elson touched on earlier, designing out anchors, for instance, is something which simply might be done from a point of view of making the balconies more cost effective. But actually, by designing an anchor out, gives a long-term benefit of reduced heat loss in the building over a period of time and brings down that carbon usage and the energy. So that's that.
I think that's a very relevant point, Nick. It's why we've obviously been working with yourselves in some schemes where we've attached the balconies to the panel, whereby we're minimizing the number of connections through your facade, which over the lifespan of a building, it's a small contribution, but it all adds up. So there are small measures that can really make a significant impact.
I think we could echo as well what others have said about the choice of materials. So one of the benefits of using aluminium decking is it's lighter weight, so it's easier to ship. It's more cost effective to ship, is easier to handle, but also it's very easily recycled. It's one of the most easily recycled metals. So as well as having a long lifespan, it always has a product value in terms of its recyclability, which is obviously a very major consideration.
Thank you. Does anyone else want to add something about that?
Yeah, if I could come in there just on sustainability in general, we've noticed that our clients now have a more sophisticated demand for sustainability, and it goes beyond the energy efficiency and carbon, which, you know, most of the clients that we would interact with, they would have a requirement for LEED or BREEAM, and previously that might have been, you know, a nice add-on to a project. It was almost an afterthought. With the NZEB legislation in Ireland, we found that you know, the whole supply chain understands now the importance of airtightness and thermal bridging. You know, and you speak about the connections to the precast and the connections to the balconies. You know, a lot of those would have thermal isolators on them, so they understand, you know, where the heat loss is, where you have those cold spots, where the building connects outside components to inside components, and that's, you know, that's evolved over the last few years in tandem with the change from, you know, polyiso insulation to mineral wood insulation. So the way of detailing buildings has changed quite a bit in the last 2 years with those changes. But one of the most interesting areas in terms of sustainability for us is what we're seeing is that the investment funds and the clients and the end users are actually looking for sustainability, and they're able to articulate that. Like, the end users are looking for healthy buildings with you know, natural materials, good ventilation systems, use of plants in the buildings, and the WELL standard is used to measure that. We're also noticing then that the investment funds are looking for sustainability benchmarking to benchmark their property investment funds against international benchmarks for ESG. So it's for, you know, their social corporate responsibility, and we find that feeds its way into the project, in that they want to, particularly for housing as well, they want to be able to measure how their building stacks up against other buildings throughout the world, you know. So we are seeing housing schemes would want to benchmark themselves against Home Performance Index or LEED Residential. And I suppose that means that sustainability, it's not just something that we add on, but it's core to the design, the specification of buildings. And, you know, we've spoken about the supply chain and shipping, manufacture, use of materials, use of low carbon materials and lower carbon materials. But the critical point you hit on there is life cycle. There's no point having, you know, a very low carbon material if it needs to be replaced after a short amount of time. I think the cost benefit analysis of materials is related to not just their impact on the construction stage, but how they will last over their lifetime. And if a component has a 50-year life cycle, it has to be easy to maintain. It has to have, materials that can be easily treated, easily cleaned. And so that does lend itself towards more robust, resilient materials and detailing. And that's really where the emphasis is on, is the buildings that will last longer, and buildings that are designed to last the test of time. And for a lot of property investors and developers, they're no longer just building just to sell and make a profit. They're building these with a long game in mind. So they're building these buildings, and they're going to manage them for 10, 20 years, and then sell on the asset at that point. But the cost of managing a building at operation stage is actually one of their biggest costs. So any systems and materials that are selected, they're not being selected just on the cheapest. They're being selected on what's actually the easiest to manage, what's the most resilient, robust system or product that can be used. And that puts more emphasis on designers, specifiers, certifiers to actually, interrogate how what products have been used and how those systems work together, how well are they weathered, what is the cleaning strategy, So it's a different approach to design and procurement, but it leads to ultimately better buildings.
That's great, thank you, Archie. I think it's definitely something that everyone is now looking into more and taking into account in the planning stages. Another question that I've had come in is about fire regulations. Obviously now with building on the increase in and around Dublin, and we've got a lot of developers and companies that are working within the UK and Dublin. Could anyone enlighten us a bit more on what the different fire regulations are, things that they need to take into consideration when working in different areas?
So in terms of the difference between the UK and Ireland obviously, and we're tending to find with the Irish the CPDs we're doing to Ireland, that a lot of people are interested in what's happening in the UK, although there isn't necessarily the obligation to follow Part B like there is in the UK. That said, doesn't mean that we'd recommend having a less safe buildings from fire performance point of view just because your project's in Ireland. Andrew, I'd be interested in your input, and Rick as well.
Certainly, as far as balconies are concerned, there are fire regulations in a whole number of different areas, and a lot of people get confused with that. So it's something we spent a lot of time on in compiling the new British standard for balconies, BS 8579, which will be published very shortly. In that it makes reference to a whole host of different standards, BS 1991 and 1999, so on, and brings them all into one place. So that's as far as balconies are concerned. It's primarily for the UK, but a lot of the standards are the same throughout Europe. So
I think there's also a couple of other instances we've picked up on. Obviously, the world at large, Andrew, when we were in Auckland doing the event back in February, we picked up there that there's an amazing interest over there in what's happening in Grenfell, and the follow through and regulations are changing in other areas of the world as well because of Grenfell. In terms of Ireland, we have found that since the Metro Hotel fire the year after Grenfell, that was obviously something which has made people perhaps a bit more fire conscious from that point of view. Rick, I don't know if you want to add anything here.
Yeah, I think it's really important, this question, because I think, as you said, Nick, we're not going to advocate going for a lesser standard. I think the standard that's been arrived at in the UK is as a result of extensive research following the Grenfell Tower disaster. And I think one of the things that we certainly are very aware of is that Part B products, Class B products in relation to fire combustibility can often issue quite a significant amount of toxic smoke. So while they may not necessarily burn substantially, the amount of smoke that's released in the presence of fire can actually have a very significant effect on any residents or inhabitants, occupants of a building. So it's really important to bear that in mind. Going for a Class A type product and Class A standard is a very significant benefit, not only in terms of non-combustibility, but amount of or the limit on the smoke that's produced as well.
I think it's something that we've seen. There's been an increasing awareness and consideration, obviously, since Grenfell. It's something we face a lot, I suppose, in some ways with our product, because it's A1 rated. Concrete's not a combustible material. The focus has shifted more to attention to detail on the detailing, and one of the things we're driven not even necessarily by the building regulations or the specifications, but we're seeing it coming from the insurance companies. And as Archie has touched on earlier, the building owners, who have obviously a lot of these schemes now are build to rent. So they have a duty of care to their tenants and residents. So what we've found is that the focus is shifted to, if you like, for example, ourselves, the panel is a robust system. It's A1 rated. So it shifts to the details of the joints. Is the fire stopping details at the floors? Is it easy to install? Can it be inspected? And the big change that we've noticed from potentially Grenfell is not necessarily just relating to fire. I think there's a far greater awareness and requirement from building owners to understand what's in their building. What is what's it made of? What is the product? Where did it come from? The traceability. And I think that's one of the probably aspects that's developed over the last couple of years that hasn't been maybe highlighted as much, but we see it becoming increasingly important.
I think you touched on a very important point there, Derek, because anyone who's listened to Dame Judith Hackett and her work realise that the problem isn't just about the fire. What that's done is uncovered a very deep-rooted lack in the building regulations, and the change that's going to come into the industry is immense. I think she cited the oil and gas industry that she came from, and how the standards have changed so dramatically since the Flixborough disaster. And I think it's upon us to become early adopters of these new standards, if you like, and not just wait for them to become regulations, but actually to be in the forefront of pushing higher standards, greater control, greater quality assurance, which of course is yet another pointer towards off-site manufacture, because it's so much easier to carry out robust and repeatable checks in a factory environment rather than on site. Archie, you probably can comment on that.
Yeah, I think you and Derek have hit the nail on the head there. That when you look at the Grenfell inquiry, you see that the design and construction process is really a collaborative. It's not really an adversarial process. It's one of collaboration, where you're only as good as the weakest player on your team. And what becomes important is this idea of making sure that information is shared and can flow, and that everyone can work towards common goals. What we've seen is that we're seeing more coordination in terms of design, but it's where the tires touch the road. It's actually where the components are fitted together, and where you have a number of different systems that need to be coordinated. We know from working with Techcrete and some of the curtain walling companies, that where you have a slab edge, you have connections, you have secondary steel, you have brackets, you have weathering, and you have insulation, you have thermal breaks, and you're trying to fit fire stopping in there, and the fire stopper isn't always the last in, and that's very difficult. It's like it's a lot of moving parts, and it's a very dynamic situation, and trying to ensure fire stopping in that location is very difficult. So the most important people in that situation are the people on the tools, the people that are fitting those systems. And that's where the emphasis needs to be. And Dame Judy Hackett talks about this golden thread of information, that all those decisions, that evidence from site, overlap of information between different stakeholders, that's all structured and managed in a way that it can be reviewed and it can be checked and it can be authorized and verified. That all becomes important. And I suppose the conversations that can happen around quality, they're helped by having a statutory process. You know, the outcomes from the building safety bill in the UK, they're probably going to be similar enough to BCAR, in that you're going to have an accountable person, you're going to have a record trail, but where that's actually very, what's important about the conversations in the UK is that they're saying, well, this isn't just about the construction stage. What's important too is that after the building is handed over, that it's managed and maintained, and that fire doors get checked every year. And what they're also doing is they're having a series of gateways. So at planning stage, the information is checked for safety. At construction stage, it's checked, and at handover stage. So there's some very useful components to the Building Safety Act, and we've also got some great lessons that we've learned from applying BCAR in Ireland. But what we've learned and what's useful about this conversation today is that all stakeholders that have input to the safety and quality of a building need to be engaged as early as possible, and all of those interfaces and interactions need to be checked early, because you don't know where the next issues are going to arise. And I think it's really interesting the way we're looking at not just the cladding, but we're looking at some of the peripheral items that are connected to the buildings, how they react in a fire. And I think that kind of risk-based approach to building safety and to looking at it from throughout the whole span of the project, from early design intent right through to operations, is really useful. And I think it's good that all stakeholders in the project can work towards that common goal, and everyone can feed into that golden thread that allows the end user to know that they got what they paid for. They have a building that's fit for purpose and safe to use.
Thank you very much, Archie.
Sorry, just following on from Archie's point there, I think it's relevant that we've never had better tools to enable us to do this coordination and to provide this link. I'm, I suppose, of a generation that's old enough to remember when drawings were done on drawing boards and then passed from one office to the other in the post. But we are in several jobs now, we're working on collaborative models, where we're working on integrated models with the steel frame, and we're embedding things like handling instructions for our panels in our models that we send to our site team. The one thing you do see coming from the UK is a lot more embedded data in the models that we're required to supply at handover. So I suppose the big advantage for us would be that if we had that extra time up front with the early engagement, that in an ideal world, I would have a digital twin built before I started on site, and then that information is passed to the site team to facilitate the sort of coordination, as Archie said, with the boots on the ground, that everybody knows what they're going to see and what they're expected to do when they get there. It's certainly something that I've seen in the past on bigger civils jobs that is now starting to translate down into buildings.
Back in February, in the event we did in the Shard, we had an analogy brought to our attention of a car in the UK. You get an MOT to show that your car is actually suitable to be driven around. Now, no manufacturer in the car industry will be aiming for that as the level of what they should achieve. That is just the minimum legal requirement for a car to drive around. And it's no doubt the same all over the world, although perhaps the standard would be slightly different between one country and another. And really, as Andrew said, the early adoption of these things in the suppliers and the industry working at a higher level, even if it's not necessarily mandatory right now, is something which, certainly when it comes to interface details, Andrew, I think you want to touch on the
I'd just like to pick up on one small detail you mentioned, Archie, about the maintenance of a fire barrier where it conflicts with, say, an arm for a balcony. And I've sat in many design team meetings where the whole team are scratching their heads how to deal with that. And it's an area where a small offsite component like the stub guard that we've developed and had tested brings a sudden solution to a very, potentially little complicated problem. It's only a very small detail, but as Derek says, the devil is in the detail, and it's those weakest links that we're really looking at to solve and bring off site.
It's those kind of products, say, if you tried doing it on site and just wrapping around, it could depend on whether it was a Friday or a Wednesday as to the quality which they actually achieved on that. And taking a small component like that, which may not necessarily take time out of it on site, although in this particular case it does, you also make it CNC machined, you take it to site and it can't actually be fitted the wrong way up. That's the kind of items and the benefits which with these smaller, perhaps less labour consuming MMC items that are actually benefiting from a fire point of view as well.
I think often what happens as well is that at design stage, a lot of these products get drawn, and then when it comes to site, the actual fitting of them gets lost in translation as it goes kind of down the chain from the design office to what happens on site. So the more that you can produce a product that is pretty obvious to fit and doesn't take any reading of instructions, it's kind of anyone can pick it up and put it together depending on what language you talk. The more we can do that through thinking off site and then bringing it to site makes it very simple and easy. It takes away a lot of the complications through communication and translation down to the ground.
That's an interesting point that you raised. I think one of the issues is that one of the downsides of the building model is when everybody models it now in 3 dimensions and everybody's working to 0.001 millimeter, people forget that we build buildings in the real world, and that a detail that works really well and has been designed and engineered to the last millimeter, it doesn't fit when potentially my panel's 6 mil to the left and the slab's 10 mil to the right. So tolerance needs built in or modeled as well.
Nick had an interesting term, DFMA, design for manufacture and assembly. And I think that seems to be the way the process is going. I have a background in architectural technology where, the construction, the 1:5 construction details was where everything came together. And I think that seems to no longer be the case. There's less emphasis on detailing. But what we're seeing is that, there's a lot more kind of prototyping of those critical details and a lot of first-of-kind benchmarks where components are assembled. All the key players are brought to site, and they're allowed. You're able to look at a particular detail. But I think BIM models can give us useful insight into that you can simulate the sequence of construction of certain elements. So I think that, those tools that we have to hand, if they're used correctly, and I suppose BIM modeling is only as good as the people that are actually using it. But as a collaboration tool, it's, it allows us to test certain assemblies and the way certain components are put together and check it virtually, rather than swing 10 tons of panel into site and find that it clashes with other components. But, I like this idea that the supply chain is actually taking the initiative on looking for solutions that make things easier to fit on site and easier to check. And we found that, in some cases, the suppliers are putting in their own quality checks, like at the factory gate, and at certain stages in construction, where they'll have their own fairly rigorous and detailed checklists and supervisor systems. And I think that goes back to the golden chain, that everyone in the construction process is feeding into creating a bigger picture of the project that shows that, no stone has been left unturned, that everything that can be done in terms of checking for quality has been done. And the people that are checking for quality are those experienced, competent, trained people who know what something looks like on site. They're not the design office engineer. They're actually the trades-based skills. The guy who knows, if a bolt or an anchor has been torqued correctly. The person who knows if something is line and level. Someone who knows if EPDM seals are done correctly, and that seems to be, what's coming out of the conversation today is that you need to know your materials. You need to know you need to know how they interact with the structure, how they interact with the secondary steel, how they interact with the weathering and thermal breaks, and that's really interesting. Is that comes out of this conversation that people within the supply chain are really passionate about quality and want their systems to be built, to the best standards available.
Yes, thank you very much for that. Obviously, very interesting subjects there that everyone has something to say. Richard, I do have a question for you about MyDeck. You did mention in your presentation about ability to install like replacement decking without like access to the residential areas. Could you go into a little bit more detail on how that works, please?
Yeah, certainly. Thanks, Kelly. It's certainly a very apropos topic right at the moment, with so many buildings being in the UK looking at being refurbished, and a lot of the buildings where they may not actually have any combustible cladding have still got combustible materials on their balconies which need to be replaced. And approaching a building through the actual, or approaching the balcony through the apartment has all sorts of challenges, costing a lot of time and arranging appointments to be able to have access to the apartment and all this kind of thing. So you can access a balcony from the outside, obviously by scaffolding the building, but scaffolding's a huge cost to a refurbishment project. And so what we've done is we've actually developed a method where we can access the balcony by using a kind of a cage and a rail system which can track up and down the side of the balcony stack without the need for scaffolding. And that it does a number of benefits. Obviously, it reduces the cost and the time of assembling and disassembling the scaffolding, but it also means that you can move the equipment around the building just where it's needed. So you haven't got the scaffolding blocking people's views or anything for weeks and months on end. It's a very mobile and versatile system that allows you to transport the materials up and down the balcony stack and the personnel. So you can have one person in the cage on the outside of the balcony, passing materials to the operative on the balcony and taking off the combustible materials, putting the new non-combustible decking down, and keeping the whole process very lean. I don't know whether that answers the question.
Yeah, and I suppose, Richard, it kind of has come just at the right time as well with COVID, and obviously trying to restrict contact with people and social distancing. So yeah, like I said, it's probably an ideal time for you now because you've kind of developed this almost as if you knew.
Yeah, no, it's been a very beneficial development, and it's something that's really allowing us to disrupt the marketplace in a significant way, reducing significant costs. I was actually having a conversation this morning with a project director, and he was highlighting that the cost of scaffolding, but not only the cost of it, but the risks that actually having scaffolding around a residential building brings, a building that's occupied. You get the risks of people climbing up it when they shouldn't. You get people complaining that it's blocking their view, blocking their light. They're stuck in their buildings because they're working from home. So he said it's a whole plethora of challenges that scaffolding itself brings. But this is a lightweight and mobile unit which can simply really speed up the whole replacement process.
That's great, thank you. I'm sure if anyone wants to find anything more about that, they can just contact yourselves on your website.
Absolutely, yeah, please be free. We're very happy. There's certain limitations to the system, but it's all down to assessing individual projects, and we're more than happy to enter into any consultation at an early stage to see how we can make that work, yeah. Great,
thank you. A final question really that I'd like to set to the whole panel, something coming, I think it's something that Archie yourself mentioned about responsibility and accountability. So obviously with everything that's we've talked about today, especially like with MSc and forward planning, at what point would you all say that responsibility is yours and the accountability for anything within that product is solely on your shoulders? Anyone last? Archie, would you like to lead? I think it was from your interview that you mentioned about it. So,
yeah, I think it was Henry Ford who said that quality is everybody's responsibility. And what we do early in the project is we try and identify who are the role holders. So who's got responsibility for design and execution. And often we find that responsibility, it's not a fixed thing. It's a very fluid thing. It moves around a bit. So, you know, the employer's design team can have responsibility at tender stage, and then when it gets to construction, that can move almost entirely across to the supply chain and to the contractors, designers. And we found over the years that sometimes responsibility and accountability are two different things. So I think some designers and some contractors are very good at you know, not taking responsibility or passing responsibility. But what we're interested in is who's ultimately accountable. You know, if something goes wrong, or if there's a defect, or if there's a problem to fix, who's accountable. So, you know, the process for building compliance in Ireland is that it's ultimately the owner's responsibility, and they delegate that responsibility to the assigned certifier and the contractor. And we manage that. We measure it, we track it, and we do it at a very granular level. So we will break down the building into its individual components. And we do this using Uniclass or Omniclass, or using some of those BIM classification systems. And we can create a very detailed map of responsibility. We can track that through the project. And we find that some suppliers, some contractors will take ownership of that, and they'll bring it forward. They'll provide information in a very detailed format. And I think it has to be almost like a science. It's you know, it's not guesswork. And over the years, you know, over all the projects we've worked with, we've learned where the high risk items are, and we take that, you know, practical risk-based approach that certain items need particular attention, and that's come up in our conversation. You know, it's those fire safe elements, it's those tricky interface details, and we've learned how to address those. And you know, it simply comes down to, you need someone who's competent, experienced, who knows their products, who knows how that product is going to interact with all the other systems on the building, and are able to demonstrate, you know, through testing, through shop drawings, through specifications, through installation guidance, and through check sheets, how those systems actually meet the rather onerous requirements now for cladding systems, for fire safe products, you know, for class A, class B materials. And you know, it is a more sophisticated environment out there. The clients expect and the state, the government expect you know, higher evidence of achieving quality and safety. And you know, that's where the industry is going. And you know, as Derek has said, we have the digital tools to enable this, and the culture is there in certain quarters, but it's not there across the entire industry. And I think it's good to see this leadership in that area from particular corners of the industry. Okay,
that's great. Did anyone else want to add to that?
What came to mind when you said that, Kelly, was one of our contractors that we work with has got a slogan, "Don't walk by," and that's specifically in regard to safety, which I think we'd all accept that we're all responsible for each other's safety. But I think you can apply it equally well to quality. That we shouldn't be, we should be learning that to not walk by. And I think what we've learned from the real market leading manufacturers throughout the world, people that we look up to, maybe let's say 3M or Hilti, these people, what you notice with there was an openness and a collaboration and the ability to ask them questions, and they'll come back and discuss your issues at an early stage without sort of an obligation to. And I think that's really what all the market leading contractors we're looking for, is that ability to, collaborate in that way. So I don't know, it's just my tuppence worth.
Following on from that, I suppose my view has been, and it's maybe more a personal view, is that the only stupid question is the one no one asks. And I think because of Archie's point about it, the difference between responsibility and accountability, I think there's always been maybe a reluctance to step outside what is your own area of expertise. But given that how complex the facades, particularly in buildings in general, are now becoming, and the level of interfaces and interfacing trades, I think part of that responsibility should be that you communicate with people. And if you have, for example, encountered a problem previously on a job, you shouldn't stand idly by and let it happen again. You have a responsibility as a part of the supply chain to discuss that or to raise that issue. So I think but second, following on from that, communication is probably the key to creating or to dealing with the responsibilities. You have a responsibility to communicate well with the other parties on the team, because it is a collaborative process.
Yeah, and you've hit the nail on the head there, Derek, in relation to the Grenfell inquiry as well. One thing which is quite clear from the live stream videos that they've had of the interrogation of different people involved in that process is there's many opportunities where people didn't ask a question, and it may not have actually been their responsibility as such, but it's kind of avoiding that situation by somebody actually asking the question, as you say.
Interesting point, Derek, what you're saying. We have had a number of times when we've had clients and contractors call us, thankfully not Sapphire schemes, but saying we've had some balconies installed and they're very bouncy. And there's not a huge amount you can do about a balcony once it's installed if it's bouncing around. So we're very conscious to be very open about what's been specified at an early stage, to say that we're concerned about rigidity on this balcony, and we kind of question the specifications involved. And I think it's important to raise issues when you see them and be open about it and say, look, this is something we're looking at every day, work with us, and we'll kind of offer something that will give you peace of mind. So it's just a typical example about, I think, is important to, when you see a problem, is to talk about it and raise it so that you don't have a problem 2 years down the line when the project's complete.
I think I agree completely. I think part of the advantage for a client in engaging an experienced supply chain is that they communicate with each other and they raise these issues early on. It's a bit like we discussed earlier about you get the maximum benefits early on in the conversation. And I think the same applies to coordinating and designing process. The more people communicate and ask questions early on, the better the benefits, or the reduced risk in this case. You're removing risk from a project by communicating effectively, which is obviously everyone's responsibility. And I think, Andrew, to go on from your point as well, in that the safety issue, I think it would be an aspiration that the quality issue is treated as seriously as safety, in terms of highlighting issues on site, spotting things, discussing them, finding out can they be improved. I think that's something that we could learn from the health and safety improvements over the last 20 years.
So the example you use there, Elson, of rigidity, the Euro codes allow for quite flexible balconies in reality, and the company would be well within their rights to manufacture a balcony right to those limits, but that's certainly not the approach we take. I know on the British standard 8579, Andrew, that's changing, isn't it, which is a sort of positive step forward.
Yeah, certainly in terms of balconies, the new British standard, which is only a recommendation, but what it's trying to do is raise the bar and put standards in place that people can aspire to, rather than just a minimum standard that people have got to comply to. So it's setting benchmarks and standards, and I think that's needed in every industry that we're dealing with. Does that help, Kelly?
Yes, that's great, thank you. So I'd like to thank everyone. Unfortunately, we've come to the end of our live Q&A panel. We've obviously covered some really interesting subjects. So obviously you were all very passionate and had a lot of experience to share with our viewers. So thank you very much for attending. And also thank you very much for your time in your interviews and presentations. It's very much appreciated. And I know the people that obviously sign up for these events have all come to hear you talk. So obviously they all value your experience and your knowledge in your chosen fields. I'd like to also thank everybody that's come to watch, whether you came and watched within your own time or watched the live stream. Thank you very much. If you do have any other questions to the panel, you can always send them to me via email and I can get them out to the panel. I'd also like to mention that Sapphire are kindly at the moment doing a PPE pack, which includes a hand sanitizer, a face mask, and a really handy hygiene key. I think everyone's seen those about recently, so they're really, really useful tool. If you'd like to claim your PPE pack, I've just put in the chat function here, the link, so you can go on there and collect it. If you haven't, if you can't use that, then just give me an email and I will send you the link. We do have a set supply of them, so please, if you want one, do apply sooner rather than later, because it's a case of once they're gone, they're gone. So let's say just let us know if you'd like one. Please keep an eye out for our future events that are coming up, and also if you'd like to book a CPD with one of our presenters, then please just come on to www.resi.build and it'll be myself that'll be in touch with you to arrange that. We have got at the moment got a couple of questions up for you, just so you can give us a little bit of feedback. We do value everyone's feedback and take it on board to try to help make sure that our events that we run for you are relevant to you and are of interest.
Just to clarify, that's a free kit, isn't it, Kelly? We're doing it as a bit of a charitable activity for the industry.
Yes, it's a free kit. So like I say, apply sooner rather than later, because everybody likes a freebie, so I'm sure they'll be flying off the shelves shortly.
Thanks, Kelly, Nick and Andrew. Really well organised and really informative as well. So thanks for that.
Good, thanks for your participation as well.